In the stillness of the night sky, a silence lingers that has haunted humanity for generations. A silence vast enough to span galaxies, a silence not of absence but of mystery. For above us, in the infinite black, lies a universe overflowing with possibility. Billions of galaxies stretch across the cosmic ocean, each holding hundreds of billions of suns. Around those suns, planets circle, countless worlds bathed in light, warmed by fire, cradled by gravity. Worlds where oceans may rise, where atmospheres may breathe, where chemistry may whisper the first fragile syllables of life. By sheer probability, the heavens should be filled with civilizations older than ours, wiser, more enduring. Civilizations that might have charted the stars long before humanity learned to kindle fire. And yet, when we listen, there is nothing. No transmissions, no signals, no great engines burning across the void, only silence. This is the heart of the Fermi paradox, the question that asks, if life is abundant, where is everybody? But now, into this silence, something arrives, a visitor from beyond, a fragment of matter, not born of our sun, but of another star. It drifts across the solar system like a messenger from the deep unknown. Scientists call it 3I Atlas, the third interstellar object ever seen passing through our cosmic neighbourhood. It comes without words, without signals, without intent, and yet it carries with it the weight of a possibility that in these silent wanderers, the universe may be whispering its first true answer. It was the summer of 1950 at the Los Alamos National Laboratory in New Mexico, a place where the human mind had already altered the fate of the world, where the atom had been split and its power unleashed. Among the desert mesas and the silence of red earth, a group of physicists gathered for lunch. They spoke, as scientists often do, of the boundaries of knowledge, of the vastness of the cosmos, of the future of technology. Enrico Fermi, one of the most brilliant minds of his age, sat quietly listening. Fermi was no stranger to the unimaginable. He had seen equations become weapons, theories transform into forces capable of reshaping civilization. And yet, on this day, his thought drifted not to Earth, but to the stars. The conversation had turned toward extraterrestrial life, toward the possibility of civilizations older, stronger, and far more advanced than ours. The idea was not new. For decades, astronomers had looked at the billions of stars above and assumed that somewhere intelligence must have bloomed. The numbers alone seemed undeniable. But then Fermi spoke. 4 words, as simple as they were devastating. Where is everybody? The table fell silent. A quiet question, asked not in jest, but with the weight of logic pressing behind it. If the galaxy is old, and if civilizations can rise and spread, then the stars should be alive with their presence. And yet, there is nothing. No radio messages, no probes, no fleets crossing the interstellar dark. Thus was born the Fermi paradox, a riddle that has haunted science and philosophy ever since. The paradox is built upon a foundation of staggering probabilities. The Milky Way contains more than 400 billion stars, and new data from the Kepler Space Telescope suggests that as many as 1 in 5 Sun-like stars may host a planet within the habitable zone, the region where liquid water could exist. That means tens of billions of potentially habitable worlds within our galaxy alone. Expand this to the observable universe, and the number of Earth-like planets soars into the trillions. Statistical reasoning suggests that life should not merely be possible, it should be common. And if even a fraction of those planets produced intelligent civilizations, then the galaxy should, by now, be a tapestry of technological activity. In the scale of cosmic time, civilizations would have had millions, even billions of years to spread. Yet the skies are silent. Our telescopes hear only the quiet hiss of natural radio noise, the whisper of pulsars, the glow of galaxies burning their light into the void. No artificial signals, no engineered beacons, no unmistakable signs of intelligence. The contradiction between these probabilities and this silence is the essence of the paradox. A cosmic riddle that grows heavier the more it is examined. Fermi's question resonated because it cuts so deeply into human expectation. For centuries, philosophers and poets had imagined the universe teeming with other minds, from the ancient Greek atomists who dreamed of innumerable worlds, to the science fiction authors of the early 20th century. Humanity assumed it was not alone. The The cosmos was too vast, too rich, too ancient to belong solely to Earth. But science deals not in dreams, but in evidence, and the evidence is silence. This silence poses not only a scientific puzzle, but a philosophical wound. If the universe is empty, what does that say about the uniqueness of Earth? About the fragility of life, about the future of civilizations? If the universe is full, then why are the others hidden? Have they chosen secrecy? Have they vanished? Or are our expectations themselves flawed? The paradox lies not in what is seen, but in what is not seen. The absence of evidence becomes, in its scale, a kind of evidence itself. To understand the weight of Fermi's question, imagine time not as the span of human civilization, but as the full breadth of cosmic history. The Earth is 4.5 billion years old, but the galaxy itself is over 13 billion years old. That means billions of years of opportunity existed before Earth was even born. If civilizations rise in that span, many could have reached technological maturity long before humanity's first steps into the cosmos. Even travelling at speeds far below the speed of light, such civilizations could have crossed the galaxy in less than 100 million years, a mere blink in astronomical terms. And yet, when we peer outward, we see no galactic empires, no great networks, no traces of travellers. The stars remain indifferent, ancient, and alone. This was the essence of Fermi's insight, that the very age and size of the galaxy, combined with the sheer probability of life, should make the universe full of evidence, and yet the silence is complete. The paradox was not immediately named after Fermi. In fact, his colleagues recalled the question more as an aside than as a formal challenge. But in the decades that followed, as astronomy advanced, the riddle gained power. Radio telescopes searched the skies for signals. Space probes mapped the outer planets. Exoplanets were discovered by the thousands. Each discovery made the universe richer, more promising, more fertile, and each discovery deepened the silence. Today, the Fermi paradox is more than just a curiosity. It is a central mystery in astrobiology and cosmology. It is the silent thread that runs beneath every search for life beyond Earth. It is the haunting refrain behind every new discovery of a distant Earth-sized planet. Because the question remains, if life can bloom in so many places, why has the universe offered us no sign that it has bloomed elsewhere? The paradox does not accuse, it does not answer, it waits. It lingers like an echo in the cosmic silence, reminding humanity that it stands at the edge of an unfathomable mystery. And into this silence, across billions of miles of interstellar space, an object drifts. It is not a signal, nor a spacecraft, nor a voice. It is a shard of another system, a fragment from a distant star. It is called 3i Atlas. It comes not as an answer, but as a question embodied in stone and ice. A reminder that the galaxy is not empty of movement, even if it is empty of voices. And perhaps within such visitors, the paradox itself begins to shift. For Fermi's question still stands, where is everybody? But in the age of interstellar messengers, the silence may be whispering back. The night sky has always been a mirror of human wonder. To the unaided eye, it appears as a quiet canvas, sprinkled with stars like scattered grains of salt across infinite black. But behind those points of light hides a scale that defies comprehension. Each star is a sun. Each sun is a furnace of fusion surrounded by planets, moons, and dust. And beyond every star, there are countless more, stretching outward into the billions. Modern astronomy has stripped away the illusion of emptiness. The Hubble Space Telescope, staring into what once seemed like blank patches of sky, revealed thousands of galaxies in a single frame, galaxies upon galaxies crowding the dark with light. Estimates now suggest that the observable universe contains over 2 trillion galaxies. Each galaxy, like the Milky Way, may hold hundreds of billions of stars. In this ocean of fire, the number of planets exceeds human imagination. Within the Milky Way alone, astronomers estimate that there are more planets than stars, perhaps more than 1 trillion worlds, and of those, tens of billions orbit within the habitable zones of their stars, where conditions could allow liquid water, chemistry, and the fragile beginnings of biology. The sheer weight of numbers bends expectation. To contemplate them is to feel the inevitability of life. If even 1 in a million habitable planets bore life, the galaxy should shimmer with ecosystems. If even 1 in 1,000 of those evolved intelligence, civilizations should be scattered like constellations across the spiral arms. And yet, the silence remains. The paradox of silence grows heavier against the backdrop of abundance. Probability suggests company. Observation delivers solitude. This contradiction is sharpened by what has been revealed in the last 3 decades. Before the 90s, the existence of planets beyond the solar system was speculation. Today, thanks to missions like Kepler and TESS, more than 500 exoplanets have been confirmed, with thousands more candidates awaiting verification. The discoveries range from scorched giants hugging their stars in tight orbits, to icy mini-Neptunes, to rocky Earth-like planets orbiting within the temperate glow of their suns. Each detection reminds humanity that Earth is not exceptional in its architecture. Planets are not rare accidents, they are the rule, and if planets are common, then so too must be the environments where life can take hold. Oceans may shimmer beneath the clouds of distant worlds, atmospheres may breathe with carbon dioxide, nitrogen, or oxygen. On some, volcanoes may churn chemistry into complexity. On others, frozen surfaces may hide warm seas, where life stirs in darkness as it once did on Earth. The Copernican principle, that humanity is not central, not unique, not the exception, whispers through every discovery. It insists that what happened here should have happened elsewhere, and not once, but countless times. Yet as telescopes peer deeper into the cosmos, the great contradiction only sharpens. The abundance of stars, the inevitability of planets, the probability of life, all build toward an expectation that the universe should be crowded with civilizations. Civilizations older than ours, more advanced, more enduring. Civilizations that might have mastered travel between the stars or reshaped their planetary homes, or left behind beacons for others to find. And still, the universe answers with silence. This silence is not an absence of sound, it is the absence of evidence. Radio telescopes like those of the SETI Institute have swept across frequencies, listening for deliberate transmissions. They have found only the hum of quasars, the static of cosmic background radiation, the natural music of the cosmos. No patterns, no artificial signals. The Great Silence is the name some astronomers give it. The expectation of voices in the void met with nothing but the indifference of stars. It is this silence that makes the numbers so unsettling, for the scale of the cosmos should not permit it. In the immensity of time and space, there should have been something, a message, a structure, a trace, and yet there is none. The statistics cut deeper when time is considered. The universe is 13.8 billion years old. The Milky Way itself formed over 13 billion years ago. Earth, at 4.5 billion years, is a relatively young world. Civilizations, if they exist, could have arisen long before humans emerged. They could have spread across the galaxy, colonized stars, and left behind their presence in every corner. Even travelling at modest speeds, the galaxy could be crossed in less than 100 million years, a blink against the canvas of eternity. If civilizations were inevitable, the stars around us should bear witness to their presence. But the sky reveals no Dyson spheres enclosing suns, no artificial constellations, no engineered anomalies. It reveals only stars, planets, and natural processes. The numbers say life, the evidence says emptiness. This dissonance is the reason silence feels so strange. It is not merely that humanity has not found others, it is that the odds of being alone seem impossibly small. But silence does not always mean absence. It may mean hiddenness, it may mean fragility, it may mean destruction. Perhaps civilizations rise but do not endure. Perhaps they collapse before reaching the stars, extinguished by wars, by resource exhaustion, by cosmic catastrophes. Perhaps they thrive but choose not to expand, turning inward instead of outward. Perhaps they are there, but so different from human expectation that their presence is invisible, woven into the universe in ways we cannot yet recognize. The numbers insist upon possibility. The silence insists upon mystery. And between them lies the Fermi paradox, the tension of abundance without evidence, of certainty without witness. Into this tension, interstellar visitors like 3i Atlas arrive like whisperers. They are not civilizations, not messages, not machines. They are fragments of distant systems drifting across the void. But even fragments carry meaning. They remind us that the stars are not separate islands, but parts of a greater ocean. Matter moves between them. Stone and ice wander from one star's grasp to another's. And if matter travels, could life, could intention. Could signs of civilizations ride within such wanderers? The paradox grows not weaker, but deeper with each discovery. The numbers fill the sky with possibilities, the silence answers with nothing. And now, drifting through that silence, the interstellar messengers add a new layer of complexity. Perhaps they are only rocks, perhaps they are more. But what is certain is this. In a universe of staggering abundance, the absence of company is no longer a simple emptiness. It is a profound mystery. And it is within this mystery that the story of Three-Eye Atlas unfolds. In October of 2017, astronomers gazing through the vast eyes of the Pan-STARRS telescope in Hawaii caught sight of something unprecedented. Against the stillness of background stars, a faint speck of light streaked across the sky, its speed too great, its path too steep to be bound to the sun. At first, it seemed to be a comet, another icy wanderer pulled from the far reaches of our solar system. But as its orbit was calculated, the truth emerged. This was no child of the sun. Its trajectory was hyperbolic, not elliptical, meaning it had not been born here and would never return. It had come from beyond the solar system, from interstellar space. Astronomers gave it a name drawn from the Hawaiian language, Oumuamua. It means a messenger from afar, arriving first. A fitting name, for it was the first confirmed interstellar object ever detected passing through our cosmic neighbourhood. The excitement was immediate. For centuries, scientists had wondered whether fragments of distant star systems might drift between the suns, slipping unnoticed into foreign skies. Now, at last, one had been caught in the act. Oumuamua was not a theory, not a speculation, but a real piece of another system, a relic of a world orbiting a star perhaps long extinguished, and yet, the more astronomers studied it, the stranger it became. Unlike most comets, Oumuamua displayed no visible tail, no bright coma of evaporating gas and dust. It reflected sunlight, but its surface revealed no clear signs of ice sublimating into space. Its brightness flickered in unusual rhythms, suggesting an elongated shape, perhaps cigar-like, perhaps flattened like a pancake. Some estimates placed its length at up to 400 meters, with a width perhaps 1/10 of that. No object in the solar system resembled it. Its color was reddish, consistent with organic rich material weathered by cosmic radiation, similar to the surfaces of distant Kuiper Belt objects. But it was its motion that unsettled astronomers most. As it passed through the inner solar system, Oumuamua accelerated slightly, as if nudged by some unseen force. The effect was subtle, but measurable. Natural comets accelerate in this way when jets of gas erupt from their surfaces, pushing them forward like miniature thrusters. But Oumuamua showed no such outgassing, no visible signs of cometary activity. The acceleration was real, but its cause remained hidden. In the months that followed, telescopes across the world turned to study the visitor. The European Southern Observatory's Very Large Telescope, NASA's Spitzer Space Telescope, arrays of radio antennas listened just in case, but the object was faint, tumbling rapidly and moving ever farther from the sun. By early 2018, it had vanished beyond the reach of even the most powerful instruments, receding toward the dark between the stars. What it left behind was not data alone, but a deep unease, for the first messenger from interstellar space had not come quietly. It had come wrapped in questions. Some scientists proposed natural explanations. Perhaps Oumuamua was a fragment of nitrogen ice, chipped from the surface of a Pluto-like world, eroding invisibly in the warmth of the sun. Others suggested a hydrogen iceberg, its sublimation too subtle for telescopes to detect. Still others imagined it as a shard of rock fractured from the collision of alien planets, hurled into interstellar exile. Each theory attempted to reconcile the anomalies, its shape, its lack of visible outgassing, its unexplained acceleration. Each provided answers, yet none provided certainty. And where science hesitated, speculation grew. The Harvard astronomer Avi Loeb advanced a provocative idea. What if Oumuamua was not natural at all, but artificial? What if it was a fragment of alien technology? Perhaps a probe, perhaps a solar sail, perhaps the discarded wreckage of a civilization long gone? Its strange acceleration could be explained, he argued, if it were pushed by the faint pressure of starlight, like a sail catching a cosmic wind. The idea divided the scientific community. Many dismissed it as premature, as a leap beyond evidence. But others noted that the data did not rule it out. For the first time, the possibility of an interstellar artifact was debated not in fiction, but in the halls of serious astronomy. Oumuamua had opened a door, and its very existence carried profound implications. If such objects drift between the stars, then the galaxy must be full of them, ejected fragments of planetary systems, shattered remnants of comets, orphaned debris wandering for eons. Some studies estimate that for every star there may be trillions of such bodies. Most pass unseen, silent and invisible in the dark. Oumuamua was a rare glimpse at the interstellar traffic that threads through the galaxy. And yet its strangeness lingers. Was it truly a natural shard, its oddities explained by exotic chemistry and erosion? Or was it something else, a messenger not only from another star, but from another mind? In the end, Oumuamua left more mystery than it resolved. Its fleeting visit was a reminder of the limits of human vision. Telescopes glimpsed only a fragment of its story, a few weeks of observation from across millions of kilometers. The rest remained speculation, written in the silence of its departure. But its impact was immense. For the first time, the abstract became real. The solar system is not isolated. It is open, porous, visited by travelers from beyond. Some are natural, some may be more, and each one carries within it the possibility of reshaping our understanding of life in the universe. The Fermi paradox asks why the galaxy is silent, why evidence of others has not been found. With the arrival of Oumuamua, the silence took on a new shape. Perhaps civilizations do not send signals across light years. Perhaps they do not build monuments to outshine their stars. Perhaps, instead, their traces are subtle, drifting quietly through space, mistaken for stone, mistaken for ice, passing unnoticed in the night. Oumuamua was the first messenger. It may not be the last. Others will come, each one carrying the weight of that haunting question. Where is everybody? And perhaps, hidden in their forms, the answer has already arrived. 2 years after the fleeting passage of Oumuamua, the silence of the heavens was disturbed once more. In late August of 2019, an amateur astronomer in Crimea, Gennady Borisov, swept the sky with a handmade telescope. Through careful patience and meticulous skill, he spotted something unusual. A faint speck of light gliding across the constellations, moving too swiftly to be a star, too persistently to be an artifact of the instruments. At first, it seemed to be another comet, one of the many icy visitors that descend from the outer edges of the solar system. But as its orbit was calculated, the truth emerged again. Like Oumuamua, this object had come from beyond. Its trajectory was hyperbolic, cutting through the solar system on a path that revealed no binding to the sun. It was designated 2I Borisov, the second interstellar object ever observed, and the first to unmistakably display the features of a comet. Where Oumuamua had bewildered with its silence and strangeness, Borisov revealed itself in a familiar language, the language of ice sublimating into gas, of dust streaming into a pale tail, of a nucleus warming as it passed near the sun. Telescopes across the world turned to follow it. The Hubble Space Telescope captured images of its glowing coma, a halo of dust and vapour shimmering around a nucleus perhaps less than a kilometre wide. Ground-based observatories recorded its tail stretching for hundreds of thousands of kilometres, a thin filament of interstellar matter unravelling in sunlight. Unlike Oumuamua, there was no doubt here. Borisov was a comet, complete with jets of carbon monoxide and water vapour. But though it behaved like a comet, it was not from here. Its 30 km per second approach speed, its steep inbound trajectory, its path through the solar system, all declared its foreign origin. Borisov was born around another star, perhaps in the icy outskirts of an alien planetary system, ejected long ago into the interstellar dark. It had drifted for millions, maybe billions of years before chance carried it into the embrace of the sun. The contrast with Oumuamua was striking. Where the first interstellar visitor had come like a riddle, silent, tailless, enigmatic, the second came like an affirmation. Borisov proved that interstellar objects are not rare curiosities, but real, tangible, and abundant. They are out there in numbers too vast to count, slipping unseen through the black, and every so often one passes close enough for human eyes to glimpse. If Oumuamua raised questions, Borisov offered grounding. Its cometary nature confirmed that planetary systems everywhere likely produce debris, icy wanderers flung outward by the gravities of giant worlds. Our solar system casts off its own comets in this way, ejecting them into the void, and so do others. The galaxy, it seems, is full of such fragments, worlds torn into pieces, frozen remnants cast loose into eternity. Yet even Borisov carried strangeness within it. Its chemistry revealed unusual ratios. Observations with the Atacama Large Millimeter Submillimeter Array, ALMA, detected high levels of carbon monoxide relative to water, a composition uncommon in most solar system comets. It suggested that Borisov may have formed in a region far colder than the birthplace of typical comets here, perhaps at the distant edge of its native system, near a star dimmer and weaker than the Sun. Some astronomers proposed that its native star might have been a red dwarf, whose faint warmth forced ices to form in extreme abundance. Others speculated that it condensed in a chaotic young system, where gravitational scattering hurled it into exile before it ever had the chance to visit its parent sun. In its chemistry, Borisov carried the fingerprints of a world never seen, of a star never named. The philosophical weight was immense, for here was an object that embodied the universality of planetary processes. The same forces that shaped the solar system, disk formation, gravitational scattering, planetary ejections, had played out around another star, light years away. Borisov was proof not only of planetary systems beyond our own, but of their kinship with ours. Every fragment like Borisov is a message in matter, a shard of cosmic history drifting across interstellar space. And if comets like these are plentiful, then the galaxy is not silent. It is littered with stories, each one waiting to be read. But as with Oumuamua, time was the enemy. By late 2019 and into 2020, Borisov made its closest approach to the Sun, its activity peaking as sunlight drove jets of vapour into space. Then, like all comets, it began to fade. Hubble's gaze in March of 2020 revealed the comet breaking apart, its fragile nucleus crumbling under the stresses of heating and rotation. Pieces of Borisov drifted apart, scattering like ash into the solar wind. By the end of the year, Borisov was gone, receding into the black, reduced to fragments too small to follow. Another interstellar messenger, passing briefly through the solar system, vanishing back into the ocean of stars. Yet in its wake, Borisov left no controversy, no unresolved acceleration, no whispered speculation of alien origin. It left something different, and perhaps more profound. Certainty. The certainty that interstellar objects are not fantasy but reality. The certainty that planetary systems across the galaxy give rise to fragments that wander endlessly. The certainty that Earth is not isolated, but open to the flow of matter between stars. If Oumuamua was a riddle, Borisov was a revelation. Together, they told a story larger than either alone. A story of abundance, of motion, of unseen currents carrying stone and ice across interstellar gulfs. For the Fermi paradox, Borisov offered both comfort and complexity. On the one hand, it reinforced the universality of planetary systems. The processes that shaped Earth are mirrored elsewhere. The cosmos is not barren of creation. On the other hand, it sharpened the silence. For if interstellar debris is so common, if matter itself moves so freely between stars, then why does life not announce itself in these wanderers? Why do they carry only chemistry and not technology? Borisov reminded humanity that the universe is not empty of traffic, the highways between stars exist, but they are filled not with fleets or signals, but with fragments of ice and stone. The galaxy speaks, but in the language of comets, not civilizations. In the end, Borisov was not a puzzle to unravel, but a mirror held up to human expectation. It showed that interstellar visitors can be ordinary, natural, and familiar. Yet it also whispered that the ordinary itself can be extraordinary when it comes from another star. For in its pale tail, stretching across space like a luminous thread, Borisov carried the story of worlds unseen. Worlds where ice is formed, where planets stirred, where gravity exiled fragments into eternal drift. It was a story written in vapor and dust, visible for only a season, then gone forever. And as it vanished into the dark, it left behind not emptiness, but anticipation. For if two interstellar objects could be found in just a few years, how many more must exist? How many messengers pass unnoticed, silent and invisible? While humanity looks elsewhere, Borisov was the second. It will not be the last. And each visitor, whether strange like Oumuamua or familiar like Borisov, deepens the mystery at the heart of the silence. Because every fragment that drifts into the solar system carries the same unspoken question. In a galaxy full of matter, full of planets, full of possibilities, where are the civilizations? In the summer of 2024, as telescopes traced their nightly sweeps across the sky, a faint point of light emerged against the still backdrop of stars. At first, it was indistinguishable from countless asteroids and comets catalogued every year. But as its path was plotted, something remarkable revealed itself. Its orbit was not elliptical, not bound to the sun's gravity. Its trajectory was hyperbolic, carrying it through the solar system on a one-way journey. It was the third time humanity had witnessed such a visitor. After Oumuamua in 2017 and Borisov in 2019, another interstellar messenger had arrived. Astronomers named it 3i Atlas, after the asteroid terrestrial impact last alert system, the Sky Survey project that first glimpsed it. Like the others before it, Atlas had travelled for ages through interstellar space. It had crossed the vast dark between stars, carrying within it the ancient memory of a world never seen, a system never known. Its approach was quiet, yet its significance immense. For with each such visitor, the solar system seemed less like an isolated island and more like a harbour along a galactic current. From the moment of its discovery, astronomers knew Atlas was different. Unlike Oumuamua, whose sudden appearance left only weeks for study, Atlas was detected months before its closest approach. This gave the scientific community precious time to prepare, to marshal telescopes across the globe and in orbit. Its brightness was faint, but measurable. Careful photometry revealed fluctuations in its light, hinting at a tumbling rotation, a body irregular in shape. Its trajectory carried it inward past the sun, a path steep and swift, with a velocity too great to have originated in the Oort cloud. Atlas, like its predecessors, was not of this solar system. It was a wanderer from elsewhere, a shard of an alien world, passing briefly through the domain of the sun before vanishing once more into the night. For scientists, Atlas was not just another discovery, it was a pattern. One interstellar object might have been chance. 2 suggested rarity but possibility. 3, in so short a span of time, spoke of abundance. The galaxy, it seemed, was filled with travellers. Statistical models recalibrated with each detection suggested staggering numbers. If 3 could be found in just 7 years with current technology, then there must be trillions passing through the galaxy at any given time, a constant flow of matter, unseen but real, threading between stars like an invisible tide. This interstellar traffic is more than astronomical curiosity. It reshapes understanding of how planetary systems form, evolve, and interact. Every comet, every asteroid, every fragment flung from its parent star contributes to a galactic ecosystem of wandering matter. To glimpse Atlas was to glimpse one piece of a larger whole, the restless exchange of worlds. And yet, with abundance comes new questions. If such visitors are so common, what do they carry? Are they sterile fragments of rock and ice, or do they bear chemistry rich with possibility? Could they transport the seeds of life between stars, carrying microbes or organic molecules across gulfs of light years? The ancient hypothesis of panspermia finds new weight in such discoveries. Oumuamua hinted at the possibility of alien technology, its unexplained acceleration fueling speculation. Borisov affirmed the natural revealing itself as a comet whose chemistry spoke of alien frost. Atlas entered this dialogue not as an answer, but as another layer of mystery. Its properties, its brightness, its very presence renewed debates that stretch back to Fermi's question, where is everybody? Because if fragments move so freely between stars, then the silence of civilizations becomes even harder to explain. As Atlas drew closer, telescopes traced its light with increasing precision. The Vera C. Rubin Observatory, nearing completion, promised to expand such searches in years to come, detecting interstellar objects by the dozens. The James Webb Space Telescope, though not designed for moving targets, turned its sensitive instruments where possible to pass the faint spectrum of Atlas, hoping to read its surface composition like a cosmic fingerprint. What was revealed was incomplete but tantalizing. Signs of dust, signs of ice, but in unusual proportions, hints of chemistry that differed from Borisov, perhaps pointing to a colder birthplace or to a star of different metallicity than the Sun. Each data point was a clue, but also a reminder. These objects carry with them the stories of alien worlds, yet their stories are written in a language still only partly understood. The presence of Atlas deepened philosophical reflection as much as scientific pursuit. For millennia, humanity had gazed at the stars as if they were unreachable. The void between systems seemed absolute, but the interstellar visitors shattered that illusion. The stars are not sealed from one another. They are connected by a ceaseless drift of matter, by shards of worlds passing endlessly between them. In this drift lies both beauty and unease. Beauty, in the realization that humanity's solar system is not alone, but open to the flow of the galaxy. Unease, in the realization that even in this flow, no trace of civilizations has yet been seen. Only rock, only ice, only tinlands. Atlas renewed this contradiction. It reminded scientists that the galaxy is dynamic, alive with movement, yet still mute in its testimonies of life. The paradox sharpened. If matter crosses so freely, why not minds? In the end, Atlas, like its predecessors, slipped away. Its closest approach passed, its brightness faded, and it receded into the deep night, too small and too distant to follow. Another fragment lost to the void, another messenger whose story remained incomplete, but its passing left humanity changed. It confirmed that interstellar visitors are not rare curiosities, but common features of the cosmos. It renewed discussions of panspermia, of alien civilizations, of the paradox of silence, and it prepared science for what comes next, the next detection, the next messenger, the next question whispered by the universe. For Atlas was not the first, and it will not be the last. Each visitor is a fleeting chance to listen, to learn, to reflect. And each one, whether strange or ordinary, carries within it the same haunting implication. The galaxy is full of motion, yet still transcendent. The silence of civilizations grows louder with every passing messenger. And yet so too does the sense that the answer may lie hidden within them. It began, as so many discoveries do, with a faint disturbance in the sky, an almost imperceptible flicker against the eternal backdrop of stars. On a warm June night in 2024, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, quietly scanned the heavens. Its purpose was not to hunt mysteries, but to guard Earth. With wide-field telescopes stationed in Hawaii, Chile, and South Africa, Atlas was built to find asteroids that might wander too close to catch threats before they arrived. But on this night, it found something different. In the flow of images transmitted from the observatory to computer screens, a point of light crept across the stars. At first, it looked like any other asteroid, a small, unremarkable speck. But when its orbit was calculated, the familiar geometry of ellipses dissolved into something stranger. This path did not loop back around the sun. It was not part of the solar system, it was hyperbolic, an arc of escape and exile. The discovery was confirmed within days. Astronomers across the world turned their instruments toward the faint light. What had been a nameless point now bore a designation: 3I Atlas, the third confirmed interstellar object, and the first discovered by a survey designed to watch over Earth. To the astronomers, the finding was both technical and human. Each interstellar object carries within it not only data, but also the echo of wonder. In the stillness of their observatories, scientists experienced a sensation older than science itself, the feeling of glimpsing something alien, something that did not belong to the familiar rhythm of the solar system. For most of human history, the stars had been silent constants, unchanging save for the slow march of planets and comets. But now, 3 times within a decade, that silence had been interrupted by wanderers from beyond. The first discovery, Oumuamua, had shocked the world with its strangeness. The second, Borisov, had confirmed that the galaxy was alive with comets cast out from alien suns. And now, Atlas stood as the third, its very existence confirming a new truth: the solar system is not isolated but porous, open to the endless flow of interstellar debris. The telescopes of Atlas are humble by cosmic standards. Their mirrors are not the largest, their resolution not the sharpest, but their strength lies in vigilance. Night after night, they sweep across vast fields of sky, photographing millions of stars and searching for the tiny motions that betray a moving body. Each image is compared against the last, the differences measured with algorithms, the faint wanderers separated from the background. It was in such a routine that 3I Atlas revealed itself. just a handful of photons captured on silicon detectors, transformed into coordinates on a computer screen. The human eye, watching those shifting points, recognized the extraordinary hidden within the ordinary. In this sense, discovery is not only about technology, but about attention. The universe is full of signals, but only through patience and awareness do they emerge into meaning. Once its interstellar trajectory was confirmed, a global collaboration began. Astronomers across continents coordinated their observations, pooling data to refine its orbit. The International Astronomical Union officially designated it as the third interstellar object ever found. The human story unfolded alongside the scientific. To those who first plotted its course, there was a moment of awe, for they knew they were witnessing not just another asteroid, but a fragment of a star system that might lie dozens, hundreds, even thousands of light years away. They were holding, through numbers and graphs, a messenger from the deep past, from the far unknown. As telescopes traced Atlas's arc across the sky, its physical nature began to emerge. It was faint, much dimmer than Borisov had. Its light curve suggested a rotation tumbling as it travelled, irregular in shape. It appeared to release dust, faint traces of activity, hinting at icy materials vaporizing in the warmth of the sun. It seemed more comet than asteroid, an echo of Borisov rather than Oumuamua. Yet its chemistry, revealed through spectroscopy, bore subtle differences. Ratios of carbon-bearing molecules, the faint signature of cyanide, the whisper of water, all told of a birthplace colder and stranger than our own. Atlas was familiar, yet not entirely. It was another thread in the tapestry of interstellar migration, woven from a star humanity might never see. For the astronomers who followed it, there was both triumph and melancholy. Triumph in having caught such a fleeting visitor, melancholy in knowing how soon it would vanish. Each observation window was brief, each night's data precious. They knew that in mere months, Atlas would fade beyond the reach of their instruments, joining the endless drift into interstellar dark. But even in its brevity, the discovery carried immense weight. It was proof that the interstellar flow is not hidden beyond imagination, but tangible and detectable. It was affirmation that the galaxy is alive with wandering messengers, fragments of alien worlds passing through the domain of the sun. Philosophically, the discovery stirred reflection. Humanity has long asked whether the stars are silent, whether civilizations rise and fall unseen in the vast dark. The arrival of 3i Atlas did not answer those questions, but it reframed them. For here was proof that material exchange between stars is real. If rocks and ice can travel such distances, could life not travel also? Could civilizations not seed their presence deliberately or otherwise across the galaxy? The faint light of Atlas was not a signal, not a voice. And yet, to those who watched, it carried the weight of a whisper, a reminder that silence is not emptiness, that the universe moves and shares, even when it does not speak. The human story of discovery is small against the backdrop of cosmic time. A faint point of light, detected on a summer night, traced across charts and catalogues, discussed in quiet meetings of astronomers, and yet, within that faintness lies the grandeur of perspective. Atlas came from beyond. It came as a fragment of a star system long distant, carrying within it the history of worlds unseen. Its presence testified to the restless exchange of matter across the galaxy. In the end, the discovery of Atlas was both scientific and existential. Scientific in the data it provided, in the numbers that revealed its path, its chemistry, its fleeting presence. Existential in the way it reminded humanity of its position in the cosmos. Not isolated, but immersed in a greater current, touched now and then by visitors from the farthest shores. And as it drifted away, it left behind not silence, but anticipation. For each detection is not an end, but a beginning. Each one suggests that more are coming, countless more, waiting to be found. In the faint light of Atlas, astronomers saw not only a comet, not only an interstellar fragment, but a promise that the story of the galaxy is still unfolding and that humanity for the first time is beginning to read it. For centuries, the solar system was imagined as a fortress of gravity, domain bound tightly to the sun. Its planets, moons, asteroids and comets that circled in ancient patterns, their motions predictable, their orbits closed. Beyond its edge stretched the void, interstellar space, vast and empty, a gulf between the stars. The discovery of Oumuamua in 2017 cracked that illusion. It was the first shard from another system, a messenger that proved the void was not empty after all. 2 years later, Borisov followed, a comet whose icy chemistry revealed the fingerprints of an alien sun. And then, in 2024, came Atlas, the third visitor. 3 interstellar objects in less than a decade. What was once thought unthinkable, catching even one such object, was suddenly becoming routine. The shock was not in their existence, but in their abundance. Before 2017, many astronomers believed interstellar visitors would be vanishingly rare. The galaxy is immense, and the chances of a stray fragment wandering close enough to be detected seemed slim. Our estimates suggested humanity might wait centuries before glimpsing even one. Yet within a handful of years, 3 had appeared. Each had arrived unannounced, slipping quietly into the solar system, discovered only by the vigilance of telescopes. Each revealed itself not as an anomaly, but as part of a pattern. Statistical models were forced to change. If 3 could be found in so little time, then the galaxy must be threaded with such wanderers. Some calculations now suggest that at any given moment, thousands of interstellar objects are passing through the solar system, most too small, too faint, too distant to be seen. The realization was staggering. The solar system is not isolated. It is immersed in a ceaseless current of matter, a galactic tide carrying fragments of worlds across unimaginable distances. This current is born from the violence of planetary systems. In their youth, stars are surrounded by disks of dust and gas, cradles where planets form. In those turbulent eons, giant planets scatter countless smaller bodies, asteroids, comets, icy fragments, some flung outward into permanent exile. Over billions of years, this process fills the galaxy with the wanderers, fragments forever cut loose from their parent suns. The 3 detected so far are only the beginning. If planetary systems like ours eject trillions of bodies into interstellar space, then the Milky Way may hold more rogue objects than stars. The galaxy itself may be less like an empty ocean, and more like a river thick with drifting debris. It is within this context that the scientific shock deepens, for such abundance reshapes not only astronomy but philosophy. If matter moves so freely between stars, then the boundaries of solar systems are not barriers but membranes. The galaxy is not a collection of isolated islands, but an interconnected sea. The implications reach further still. If comets and asteroids can drift between stars, could they carry with them the raw materials of life, the building blocks of biology? Amino acids, carbon chains, even frozen microbes could, in principle, survive the long journeys through interstellar space. The hypothesis of panspermia, once regarded with skepticism, finds renewed plausibility in this interstellar current. Life may not need to arise anew on every world. It may drift, seeded from star to star by fragments cast outward in cosmic storms. If so, the galaxy might be less a void of lonely beginnings and more a garden connected by hidden roots. Yet the paradox remains. If fragments cross so freely, why not civilizations? If the galaxy is alive with motion, why not alive with voices? Why do these messengers carry only silence? For scientists, the shock lay not only in the numbers, but in the timing. Humanity has been scanning the skies for barely a century. Only recently have telescopes gained the sensitivity to detect such faint, fleeting objects. What are the chances that within a few short years, 3 would pass close enough to be seen? The simplest answer is also the most profound. This is not coincidence, but inevitability. The galaxy is filled with wanderers. Humanity has finally built the tools to notice them. In the coming years, the Vera C. Rubin Observatory, with its sweeping wide-field surveys, is expected to find many more. Some estimate that once its operations begin, interstellar objects may be detected yearly, perhaps monthly. What was once an anomaly may soon become a new field of study, the archaeology of alien systems carried out through their fragments. The philosophical resonance is inescapable. For thousands of years, humanity has gazed at the stars and asked whether the void between them was absolute. Now, the answer is emerging. The void is not empty. It is filled with motion, with fragments, with whispers of worlds unseen. The interstellar current is a hidden river, and Earth drifts within it. But this abundance does not diminish the mystery. It intensifies it. If debris flows so freely, then surely civilizations too could spread. They could launch probes across the galaxy, small machines riding the same currents. They could leave signatures etched into fragments, signals hidden in stone. Yet so far none have been seen. The silence grows louder against the background of abundance. 3 visitors in less than 10 years were enough to overturn old assumptions, enough to prove that the solar system is open, not closed, enough to reveal that interstellar space is not barren, but full of travellers, and enough to deepen the contradiction at the heart of the Fermi paradox. Because if rocks can cross the galaxy, why not voices? If fragments can wander freely, where are the civilizations? The scientific shock of Atlas, and of the current it revealed, is not merely in numbers or trajectories. It is in the way it shifts perception. The universe is no longer a still stage, but a restless sea. The solar system is no longer an island, but a harbour in a galactic tide. And humanity is no longer alone beneath silent stars, but surrounded by countless visitors, most unseen, flowing endlessly through the dark. In this current lies both promise and mystery. Promise that each new detection brings the chance to learn, to read the stories of alien worlds in their chemistry. Mystery that amid this abundance, the silence of civilizations remains absolute. The shock of Atlas was not simply that it was found. The shock was that its presence revealed a truth already around us. The galaxy is alive with motion, and we have only just begun to notice. When a single visitor appeared in 2017, it was an anomaly, an event so improbable that it seemed like chance. When a second arrived in 2019, it suggested that chance was less unlikely than once thought. But when a third was discovered in 2024, the anomalies began to resolve into something greater, a pattern. Oumuamua, Borisov, Atlas, 3 messengers from the interstellar dark, 3 fragments from alien stars, each different in form, in behaviour, in chemistry, yet bound together by their origin beyond the sun. Together, they began to reveal the hidden structure of the galaxy's restless debris. Their trajectories told the first part of the story. Oumuamua entered swiftly, on a path tilted steeply against the plane of the solar system. It moved too fast to be captured, racing away before telescopes could fully understand it. Borisov arrived next, plunging inward on a steeper angle, a true comet with a hyperbolic orbit so pronounced that its foreignness could not be mistaken. And Atlas, the third, followed yet another unique trajectory, its inbound speed and arc of passage consistent with an origin beyond the Oort cloud carrying the unmistakable signature of interstellar exile. Though each took a different path, all 3 bore the same fundamental truth. They did not belong here. Their motions betrayed them as wanderers, not residents. Their velocities, tens of kilometers per second relative to the sun, were far greater than those of ordinary comets. They carried with them the inertia of stars unseen, the gravity of birthplaces scattered across the spiral arms of the Milky Way. Brightness told the second part. Oumuamua reflected sunlight in strange, uneven rhythms. Its light curve rose and fell dramatically, suggesting a body elongated or flattened, tumbling through space. Its brightness did not behave like that of an ordinary asteroid, nor like that of a comet, for it shed no visible tail. It was silent in both light and gas. Borisov, by contrast, glowed like a comet should. Its coma expanded as sunlight warmed it, jets of dust and gas streaming outward, scattering light into a long, delicate tail. To telescopes it was a familiar sight, yet tinged with the thrill of knowing it had come from beyond. Atlas, dimmer and more elusive, seemed to fall between these extremes. Its light suggested dust, faint activity, perhaps ice sublimating in the sun's warmth, but not as dramatic as Borisov. It was neither silent like Oumuamua, nor exuberant like Borisov, but something in between, a fragment that whispered rather than shouted. The third clue lay in their chemistry. Borisov, studied in detail, revealed an unusual ratio of carbon monoxide to water, hinting at a birthplace colder than most comets in our solar system. It seemed to have formed far from the warmth of its parent star, in a frozen outer realm. Oumuamua's chemistry remains a riddle. Without a coma, no gases could be measured directly. Its reddish hue suggested organic compounds weathered by cosmic radiation, but its unexplained acceleration left the possibility of exotic materials, perhaps hydrogen ice sublimating invisibly, perhaps nitrogen frost, or, in speculation, perhaps something artificial. Atlas, faint though it was, offered glimpses of its own signature. Spectroscopic hints suggested a mix of volatiles distinct from Borisov, yet still bearing the hallmarks of frozen origins. Each visitor carried its own chemical fingerprint, a reflection of the system that birthed it. Together, they whispered of diversity, planetary nurseries scattered across the galaxy, each producing fragments shaped by their unique conditions. Taken alone, each messenger is a puzzle. Taken together, they form a revelation. These three objects demonstrate that interstellar debris is not uniform. It is not one kind of rock nor one kind of ice, but a spectrum of forms, each shaped by the violence and variety of alien systems. Some are silent shards, tumbling enigmas like Oumuamua. Some are comets, flamboyant in their evaporation like Borisov. Some are faint hybrids, ambiguous and in between like Atlas. In their diversity lies a reflection of the galaxy itself, chaotic, creative, and endlessly complex. Patterns also emerged in their timing. To detect 3 within 7 years suggests that such objects are not rare accidents, but common features of the cosmic landscape. The interstellar current is real, and humanity is only beginning to sense its flow. This realization carries profound implications. For if debris is so plentiful, then every star system in the Milky Way must be shedding its fragments into space and realm. Over billions of years, these fragments mix and mingle, crossing paths, drifting endlessly. The galaxy becomes not a collection of isolated systems, but a network connected by wandering stone and ice. And if matter moves so freely, what else might move with it? Could fragments carry not just chemistry but biology, frozen microbes or molecules capable of sparking life on alien worlds? Could the seeds of life itself ride the interstellar current? The patterns hint not only at abundance but at possibility, yet the silence remains. For while matter flows abundantly, no sign of civilization has yet been carried with it. No fragments etched with signals, no probes hidden in disguise, no undeniable artifacts of intelligence. This absence sharpens the paradox. The diversity of debris proves that planetary systems are common. The abundance of detections proves that interstellar traffic is constant. And yet, amid all this, the galaxy remains mute. Perhaps civilizations do not survive long enough to seed the current with their creations. Perhaps they are there, but their artifacts are indistinguishable from natural stone. Or perhaps humanity has not yet learned how to look. In comparing the 3 messengers, astronomers do more than catalogue properties. They glimpse the architecture of the galaxy's hidden exchange. They begin to see the outlines of a cosmic ecosystem, one in which every star system contributes, every ejection adds to the tide, every fragment becomes part of a shared galactic story. The pattern is both scientific and philosophical. It tells of abundance but also of absence. It reveals the galaxy as dynamic but also as silent. Oumuamua, Borisov, and Atlas are not the end of this story, but its beginning. They are the first voices in a chorus not yet heard, the first ripples of a current that flows unseen. With each new detection, the pattern will sharpen. Differences and similarities will reveal not only the variety of alien worlds, but the hidden rules of the galaxy itself. And within that pattern, perhaps, lies the first true hint of an answer to Fermi's question. For if the galaxy is full of fragments and yet devoid of civilizations, then silence itself may be telling a story. The first interstellar object, Oumuamua, was received with astonishment. The second, Borisov, with confirmation. The third, Atlas, with inevitability. What once seemed like a rare cosmic accident now appears to be part of a ceaseless rhythm. Fragments of alien worlds flowing into the solar system as naturally as tides lap against a shore. Yet this recognition carries with it a deeper unease. If such visitors are common, then why did humanity only begin to see them in the last decade? If the galaxy is awash with interstellar debris, then how long have these wanderers been slipping past unnoticed? The answer lies partly in limitation. Until recently, the instruments of astronomy were not suited to detect such faint and fleeting travellers. Oumuamua, only a few hundred meters long, was visible for just 11 days of high-quality observation before fading beyond reach. Borisov, brighter but still small, was detected by the vigilance of a single amateur astronomer. Atlas was caught only because a survey system designed for planetary defense scanned tirelessly across the heavens. In truth, these visitors may have been arriving for eons, each passing unseen, each vanishing into the dark without a trace. The absence of discovery was not the absence of presence, it was the absence of vision. Now, with new instruments and global surveys, humanity has begun to pierce the veil. What appeared rare is revealed as abundant. The solar system is not a closed stage, but a crossroads bathed in a hidden current of interstellar matter. This current is not metaphor alone. Astronomical models predict that planetary systems, in their chaotic youth, eject trillions of fragments. Over billions of years, these fragments disperse, drifting across the galaxy in vast numbers. The Milky Way itself becomes a reservoir of wandering comets and asteroids, more numerous than the stars that light its spiral arms. The solar system, orbiting in its quiet lane of the galaxy, is immersed in this drift. Invisible to the naked eye, unnoticed for centuries, it flows constantly through the realm of the sun. To live within the galaxy is to live within this river. The escalation of discoveries, 3 and 7 years, suggests that humanity is only now becoming sensitive to the current in which it has always been adrift. And yet, this realization unsettles as much as it illuminates. For abundance deepens the paradox. If rocks and ice wander so freely between stars, why has no fragment yet borne unambiguous signs of life or of intelligence? If billions of interstellar objects pass through the galaxy, why has none yet carried a signal, a structure, or an artifact that speaks of civilization? The silence, set against such abundance, becomes even stranger. Some scientists have speculated that interstellar objects may number in the quadrillions. If so, then the solar system may be crossed by several each year, most too faint to detect, but present nonetheless. Some estimates suggest that in every cubic parsec of the galaxy, billions of interstellar fragments drift. The stars are not separated by emptiness, but by a fog of debris. This realization forces a re-evaluation of the solar system's place in the cosmos. Earth and its neighbouring planets are not solitary within an isolated bubble of space. They are immersed in the detritus of countless alien worlds. Each fragment carries the memory of a birth elsewhere, a cometary crust formed around a red dwarf, an icy shard cast outward by a gas giant, a rocky splinter torn from a planet's collision. To stand on Earth and look upward is to gaze not into silence, but into a sky threaded with invisible travellers. The escalation raises another possibility, an unsettling one. If interstellar fragments are so abundant, then they may have brushed against Earth many times before. Some may have plunged into its atmosphere, burning unseen as meteors. Others may have struck its oceans, dissolving into salt water, their alien chemistry mingling unnoticed with the Earth's own. Perhaps some left molecules behind, catalysts of life or whispers of worlds beyond. If panspermia is more than speculation, then Earth itself may already bear the imprint of this current. Life here could be a hybrid, seeded not solely from local chemistry, but from the contributions of many stars. In this sense, Earth may not be unique, but a node in a galactic network of exchange. And if that is true, then silence becomes more haunting still. For if life is so freely seeded, then intelligence should not be rare. Civilizations should emerge, multiply, and leave their traces. Yet the fragments remain mute. The psychological weight of this escalation is profound. To know that the solar system is porous, that interstellar matter flows through it constantly, is to feel connected to the galaxy in ways once unimaginable. But it is also to feel the contradiction sharpen. Abundance without evidence, current without signal, motion without meaning. Perhaps the answer lies in time. Civilizations may rise and fall too quickly to fill the current with their creations. Their lifespans may be brief compared to the eternity of stone. Fragments survive for billions of years, while civilizations may last for mere millennia. The galaxy's river carries matter endlessly, but intelligence may appear and vanish too quickly to leave its mark. Or perhaps civilizations choose silence. Perhaps they ride the current unseen, their artifacts hidden among the natural debris, indistinguishable from comets and asteroids. Perhaps the difference between the artificial and the natural is subtler than humanity yet knows how to perceive. The escalation of interstellar detections is both scientific revolution and philosophical wound, for with each new object the sense of abundance grows, while the silence of civilizations deepens. Humanity is learning to see the current it has always inhabited, but it has not yet learned to hear what, if anything, the current may carry. Oumuamua, Borisov and Atlas are not isolated events. They are the first raindrops on the surface of an unseen ocean. They suggest a galaxy alive with motion, saturated with fragments, dynamic and connected. But they also amplify the paradox. If the galaxy is so alive with matter, why does it appear so dead with minds? The solar system is bathed in an unseen current. Every detection is not the arrival of rarity, but the revelation of what has always been. The question now is not whether these visitors exist, but what they mean. Are they only debris, or are they the faint echoes of civilizations, too subtle to yet discern? The escalation does not close the mystery, it expands it. When Oumuamua swept through the solar system in 2017, it left more questions than answers. Its elongated form, its tumbling motion, and above all, its unexplained acceleration turned a fragment of stone into a spark of controversy. Some saw in it nothing more than exotic physics, hydrogen ice sublimating invisibly, or nitrogen frost eroded into improbable shape. But others saw something more provocative, the possibility that it was not natural at all. Among the loudest voices was Avi Loeb, a theoretical astrophysicist at Harvard University. In a bold proposal, he suggested that Oumuamua's behavior was consistent with an artificial origin, perhaps a fragment of alien technology, or a thin solar sail propelled by the faint pressure of starlight. For many in the scientific community, the claim was too far. The data was too sparse. The anomalies too easily explained by natural processes. To call it artificial, they argued, was to leap beyond evidence, and yet the door had been opened. For the first time in serious journals and conferences, the possibility of alien artifacts was debated not as fiction, but as hypothesis. The debate did not end with Oumuamua's departure. When Borisov arrived in 2019, its cometary behaviour seemed to restore balance. Here was an interstellar object that behaved like a comet should, its gases and dust easily explained. To many, Borisov was the reassurance that Oumuamua had been the exception, not the rule. But then came 3I Atlas in 2024. Dim, irregular, partly comet-like, but not as flamboyant as Borisov, it once again stirred uncertainty. Its discovery renewed not only discussions of abundance, but also of intention. Could some of these objects be artificial? Could the galaxy's interstellar current hide probes, disguised within the flow of debris? The idea is not new. Decades earlier, physicist Ronald Bracewell had proposed the concept of Bracewell probes, autonomous machines that could drift between stars, carrying knowledge, observing civilizations, or even waiting stagnantly for contact. Unlike radio signals, which fade with distance and time, probes could endure, crossing the galaxy slowly but persistently, outlasting their makers. If civilizations wished to explore without rushing, if they sought to scatter their presence widely, then probes could be the natural choice. And where would such probes hide most effectively? Among the countless fragments of stone and ice already drifting between the stars. In this light, the abundance of interstellar objects takes on new significance. What appears to be only natural debris could, in theory, conceal artificial messengers. Humanity may already have glimpsed one and dismissed it as anomaly. Avi Loeb's arguments returned with Atlas. In interviews and papers, he pointed to the improbability of dismissing anomalies too quickly. He argued that science must be open to the extraordinary when data resists conventional explanation. Perhaps not every interstellar object is artificial, but even if 1 in a million were, the implications would be profound. The divide within astrophysics deepened. Some accused Loeb of sensationalism, of distracting from the sober task of studying natural processes. Others defended him, noting that scientific revolutions often begin with bold questions. What is dismissed as impossible may later be revealed as overlooked. This debate does not weaken the field, it sharpens it. Between skepticism and speculation lies the crucible where understanding grows. What would it mean if even one interstellar visitor were artificial? The thought stretches imagination to its limits. It would mean that another civilization had not only risen, but endured long enough to spread. It would mean that the silence of the Fermi paradox is not silence at all, but whisper, subtle, concealed, awaiting recognition. Perhaps civilizations do not flood the galaxy with radio signals. Perhaps they do not build megastructures to catch attention. Perhaps, instead, they send their messengers quietly, hidden in plain sight, drifting among the comets and asteroids. The idea is both thrilling and unsettling. Thrilling because it suggests humanity is not alone. unsettling because it suggests contact may already have happened, unnoticed. Yet science demands caution. Oumuamua's data set was painfully thin. Its acceleration could have been driven by sublimating gases too faint to see. Its shape could have been sculpted by collisions and erosion, not engineering. Atlas, though intriguing, showed traces of volatile activity consistent with cometary behaviour. To leap from anomaly to alien probe is to step into uncertainty, and still the speculation lingers. For the anomalies resist complete dismissal. They remain like whispers at the edge of hearing, never resolving into clarity but never fading away. The controversy reveals as much about humanity as about the objects themselves. The hunger to know, the willingness to imagine, the refusal to dismiss the extraordinary, these are the traits that drive discovery. Skepticism anchors, speculation propels, and between them truth is sought. The alien hypothesis, whether true or false, performs a necessary function. It forces science to look closer, to demand better instruments, to build missions that might one day intercept such objects directly. Already, proposals exist, spacecraft launched to chase the next interstellar visitor, to sample its dust, to photograph its form, to resolve speculation with evidence. In this way, the debate itself becomes a catalyst. Whether or not Atlas, Borisov, or Oumuamua were artificial, the question ensures that future visitors will not be ignored. Philosophically, the alien hypothesis touches something deeper. It reveals the tension between silence and expectation. If the galaxy is full of matter, why is it empty of voices? If civilizations exist, why do they not announce themselves? Perhaps the answer is that they do, but not in the way expected. Perhaps their presence is not in radio waves, but in stone, not in light, but in shadow. In this light, the interstellar current becomes not only a river of debris, but a potential archive. Among the countless fragments, there may be a handful that are not natural at all. Humanity may already have seen them, but lacked the vision to recognize them. The alien hypothesis is not a conclusion, it is a possibility. It does not claim certainty, but it refuses complacency. It asks that the strange not be dismissed too quickly, that anomalies be treated not only as errors to be explained away, but as potential windows into something greater. Whether Atlas was a comet, a shard, or something else entirely, its presence renews the question. It forces reflection on the paradox. If the galaxy is alive with motion, yet silent in signal, then perhaps the signals are written in matter, not in light. Perhaps the messengers are not beams across the void, but travellers drifting quietly past. The return of the alien hypothesis is less about proof than about perspective. It reminds humanity that in the vast silence of the cosmos, certainty is scarce and humility is essential. For one fragment of stone accelerated by unknown means was enough to rekindle the oldest of questions. And each new interstellar visitor, whether ordinary or extraordinary, ensures that the question will not fade. The Fermi paradox begins with contradiction. The galaxy is immense, its stars uncountable, its planets innumerable. By every measure of probability, life should not only exist, but thrive. Civilizations should arise, expand, endure, yet the sky remains silent. No signals, no artifacts, no signs of company, only the unbroken stillness of stars. Into this silence 3 messengers have arrived. Oumuamua, Borisov, and Atlas, each born around a star not our own, each carrying within it the chemical fingerprints of alien systems. Each proof that the gulf between stars is not empty but alive with motion. And in their presence the paradox deepens. If matter travels so freely, then isolation is an illusion. The solar system is not sealed. It is porous, bathed in a ceaseless current of interstellar debris. These fragments are not rare anomalies. They are the fabric of a galaxy in motion. Some models suggest there may be more interstellar objects than stars. Quadrillions of silent wanderers scattered like seeds across the spiral arms. And if seeds, then perhaps more than seeds of stone. Perhaps seeds of life. The idea is known as panspermia. It proposes that life does not always begin anew, but spreads, riding on comets, on asteroids, on fragments flung into the dark. Within protective shells of ice and rock, microbes or organic molecules could endure the long sleep of the interstellar exile. Shielded from radiation, frozen against decay, they might awaken again upon reaching a hospitable world. On Earth, amino acids have been found within meteorites. Complex organic molecules have been detected in interstellar clouds and on the icy surfaces of comets. Life's building blocks are not confined to Earth. They are written into the chemistry of the cosmos. The leap from chemistry to biology remains uncertain, but the possibility cannot be dismissed that worlds may be seeded not in isolation, but by a galactic current. In this light, visitors like Borisov and Atlas are not mere fragments of ice. They are potential carriers of biology, threads in a vast web of exchange that binds planets and stars. If panspermia is true, then the galaxy itself is a garden, and its gardeners are comets. But the paradox presses further. If life spread so freely, then intelligent life should not be rare. Civilizations should bloom across the galaxy like wildflowers in rose spring. And if civilizations spread, then the interstellar current may not carry only natural fragments, it may also carry intention. Here lies the most provocative speculation, that interstellar objects may not be random at all, but deliberate. Probes scattered by civilizations seeking to explore, to observe, to seed. Silent machines drifting in disguise, indistinguishable from natural debris. The idea is not without precedent in human imagination. In 1960, Ronald Bracewell suggested the possibility of autonomous interstellar probes, now known as Bracewell probes. Instead of broadcasting radio signals across light years, civilizations might send emissaries to drift patiently, to wait and listen, to outlast their makers. A probe could survive for millions of years, enduring where civilizations may not. If even a fraction of stars gave rise to such efforts, then the galaxy could be filled with these hidden emissaries. And where better to conceal them than among the endless current of natural fragments? The paradox sharpens. Humanity expects to hear civilizations, but perhaps civilizations do not speak in radio waves. Perhaps their messages are written in stone, drifting quietly past, mistaken for comets and asteroids. Perhaps the galaxy is not silent, it is speaking in a language not yet recognized. Oumuamua, with its unexplained acceleration, forced this question into the open. Was it natural or was it something more? The evidence was inconclusive, but the speculation it sparked revealed how fragile the boundary is between anomaly and artifact. Borisov seemed to restore the natural order, a comet behaving as comets do. Yet Atlas, dim and ambiguous, reawakened the uncertainty. Together the three form a dialogue with the paradox itself. The abundance of debris confirms the interconnectedness of the galaxy. The anomalies suggest possibility. The silence of civilizations grows harder to accept as emptiness and easier to imagine as concealment. If panspermia is real, then interstellar fragments may carry life between stars. If probes are real, then interstellar fragments may carry intelligence between stars. In both cases, the galaxy becomes a place of exchange, not isolation. The current becomes a medium not only of matter, but of meaning. The paradox then transforms. It is no longer the question of where is everybody. It becomes instead a question of perception. Are we looking in the wrong way? Perhaps civilizations are not absent, but present in subtler forms. Perhaps they do not shout across light years, but whisper through objects. Perhaps the evidence of life or of mind drifts already past Earth, hidden in plain sight. The thought carries both wonder and dread. Wonder because it suggests that humanity may not be alone, that the galaxy may be alive with civilizations whose traces drift everywhere. Dread because it suggests that humanity has already encountered them and failed to notice. For thousands of years, Earth has been bathed in the interstellar current. Fragments may have entered its atmosphere, fallen into its seas, scattered across its deserts. If even one of these fragments carried biology or intention, then contact may already have happened, not in messages, but in matter. The paradox then is not silence, but blindness. The arrival of Atlas sharpened this possibility. 3 interstellar visitors in 7 years are not accidents. They are windows. Each one is an invitation to look closer, to search not only for natural origins, but for signs of the extraordinary. Future missions may one day intercept such objects, sending spacecraft to examine them directly, to search their surfaces for chemistry or technology. Until then, humanity must dwell in the tension between possibility and ignorance. The paradox remains unresolved but enriched, not silence against abundance, but silence within abundance. And so the visitors stand as symbols of the paradox itself. Oumuamua, the anomaly, Borisov, the affirmation. Atlas, the continuation. Together they suggest that the galaxy is alive with motion and perhaps with meaning, but they also remind us of how much remains unseen, how easily the extraordinary can masquerade as the ordinary. The Fermi paradox is no longer an abstract riddle of probabilities. It is now a tangible mystery, tied to real objects drifting through the solar system. The question is no longer where is everybody. The question is whether we are able to recognize them when they arrive. Across the sweep of the Milky Way, 400 billion suns burn. Around many of them, planets circle, cloaked in atmospheres, mantled in oceans, sculpted by storms. Some are scorched wastelands, others frozen deserts. But among them, logic insists, there must be havens, worlds where chemistry awakened, where biology stirred, where intelligence might have risen to gaze back at the stars. And yet the sky is empty of voices. This absence is known as the Great Silence. A silence more profound than emptiness, because it resounds against expectation. Probability insists on presence, yet observation delivers nothing. For over half a century, humanity has listened. The vast dishes of the SETI Institute, the Arecibo Observatory before its collapse, the Green Bank Telescope, and now the Allen Telescope Array, all have swept across the spectrum, searching for artificial signals. Across billions of frequencies, they have heard only natural static, the hiss of hydrogen atoms, the pulsing of neutron stars, the cosmic microwave background, the primordial echo of creation. No messages, no patterns, no beacons. If civilizations exist, they do not speak in the language humanity has expected, nor has the silence been broken by sight. Telescopes capable of detecting the dimming of stars by planets have not found stars dimmed by Dyson spheres, the hypothetical megastructures once imagined as hallmarks of advanced civilizations. No engineered patterns of light streak across the sky. No great cities shine in the darkness of alien worlds. The absence of the obvious has left the paradox sharper than ever. If civilizations rise, why do they not make themselves known? One possibility is destruction. Civilizations may rise but burn out quickly, extinguished before their signals can spread far. They may succumb to their own technologies, to wars, to climate collapse, to the fragile balance of survival. In this view, the galaxy is not empty but haunted. Its it's a graveyard of civilizations erased before their voices could endure. Another possibility is restraint. Civilizations may endure but choose not to broadcast. They may fear detection, remaining hidden, or they may find little value in shouting across light years, preferring quiet introspection over expansion. And another, stranger possibility is concealment. Civilizations may be present, but their traces are subtle, hidden within the fabric of the natural. Not in grand structures, but in small artifacts. Not in signals, but in swants. Here, the interstellar visitors return to focus. Oumuamua, Borisov, Atlas. To most they appear as natural debris, fragments of ice and stone, relics of alien systems, but perhaps within them lies a subtler presence. Perhaps civilizations do not reveal themselves with towering beacons or galaxy-spanning structures, but with whispers carried on the currents of matter. An object drifting quietly between stars could be a probe, a vessel of information, a seed of life. It would not shine brighter than a comet, nor sing louder than the static of space. It would pass as ordinary, indistinguishable from countless fragments. To recognize such artifacts requires more than listening. It requires a new kind of seeing. The Great Silence may therefore not be silence at all, but a failure of perception. Humanity has expected civilizations to reveal themselves with grandeur, but perhaps grandeur is rare. Perhaps survival requires subtlety. Perhaps the traces of intelligence are hidden not in the scale of the colossal, but in the scale of the small. The philosopher John Archibald Wheeler once wrote that the universe gives no answers unless you ask the right questions. Perhaps the right questions have not yet been asked. Perhaps the right instruments have not yet been built. For in every fragment that drifts through the solar system, there lies a possibility, however faint, that it is more than it seems. A shard of alien stone, yes, but also potentially an artifact, disguised within nature's flow. This perspective does not eliminate the silence, it reframes it. Instead of emptiness, kaisis, there is mystery. Instead of absence, there is ambiguity. The silence becomes a veil, not a void, and within this veil, the interstellar visitors loom larger. Each one may be a test of perception. Humanity sees a comet, humanity sees a shard, but perhaps Beneath the surface, there is something else, something waiting to be recognized. The great silence thus becomes more haunting than emptiness, for emptiness would mean that Earth is truly alone, a solitary spark in a dark universe. Silence within abundance, however, suggests something stranger, that presence may exist but remain invisible, that civilizations may endure but conceal themselves, that the galaxy may be alive but not in a way humanity yet knows how to measure. Into this silence the interstellar current flows, carrying with it both certainty and uncertainty. Certainty that fragments of alien systems pass through the solar system with regularity. Uncertainty that their meaning is unknown. Are they only debris, or are they whispers, only matter, or also message? The silence offers no answer. It waits, immense and unbroken, pressing against imagination. For now, humanity dwells in paradox. It listens and hears nothing. It looks and sees only nature. Yet nature itself delivers anomalies, an object accelerating without visible cause, a comet whose chemistry tells of a star never known, a fragment tumbling into and out of the solar system's grasp. Perhaps the silence is not the absence of voice, but the presence of voices unheard. Perhaps civilizations speak not as humans expect, but in ways that pass unnoticed, hidden in the quiet travelers of the interstellar current. The great silence endures. It is vast, patient, and unbroken, but within it 3 visitors have appeared in a handful of years, each a reminder that silence is not emptiness, and that the galaxy is not still. The paradox grows sharper, the silence grows deeper, and the interstellar messengers, fleeting and enigmatic, may be the first clues hidden within it. For silence is not always the absence of sound. Sometimes silence is the presence of meaning not yet understood. The discovery of 3 interstellar visitors within a span of 7 years was not merely coincidence, it was revelation. It suggested that the solar system is not a fortress, but a crossroads. That the space between stars, once thought to be empty, is instead alive with motion. From this realization, a new hypothesis emerged, one that reshapes humanity's perception of the galaxy. There may not be millions of such objects, not even billions, but quadrillions, a population so vast that for every star, there may be trillions of fragments wandering the dark strewn across the spiral arms like sand across a shore. The numbers are staggering. After the detection of Oumuamua in 2017, astronomers began to model how many such objects might exist given the improbability of seeing one at all. Their estimates pointed toward the unimaginable, perhaps 1026 interstellar objects drifting through the Milky Way, more than the stars, more than the planets, more even than the grains of dust that fill the nebulae. If true, then the galaxy is not a void punctuated by suns, it is a vast ocean, and these wanderers are its currents, unceasing, innumerable, omnipresent. Every star is a source, every planetary system in its youth ejects fragments through gravitational violence. Icy comets hurled outward by giant planets, rocky shards blasted into exile by collisions, debris scattered into eternity. Over billions of years, these expulsions accumulate, saturating the galaxy with stone and ice. In this view, the Milky Way itself is less a still expanse and more a storm of fragments, a restless migration of matter between stars. This abundance reframes the Fermi paradox, for if quadrillions of objects wander the galaxy, then the distances between civilizations may not be barriers at all. The current provides natural pathways of exchange, biology could ride within it. Technology could hide within it. Intentional artifacts could disperse across it. This is why some theorists propose that among the quadrillions of natural wanderers, a minority may be artificial. Machines designed to endure, probes disguised as comets, messengers seeded across the galaxy, riding the same currents that carry debris. To search for life among the stars may therefore not be to look only for signals, but to examine the wanderers themselves. The sheer number of objects also transforms planetary science, for it implies that the solar system itself is constantly intersected by this galactic tide. At any moment, thousands of interstellar fragments may be present, too faint, too small or too distant to detect, but real nonetheless. Most will pass without notice, vanishing into the night. A few by chance and vigilance are caught, faint points of light tracked by telescopes, catalogued before slipping away. The abundance is not only statistical, it is physical. If every star system contributes to the current, then every interstellar object carries the memory of a different birthplace. Some formed in the icy outskirts of dwarf stars, others condensed in the disks of massive suns. Each is a geological time capsule, a fragment of planetary processes alien to Earth. In their diversity lies a record of the galaxy's creative power. The theories of abundance also echo through the philosophy of existence. If the galaxy is saturated with fragments, then the isolation of civilizations is harder to reconcile. The interstellar current is not empty but crowded, and yet, amid quadrillions of objects, not one has yet been confirmed as artificial. Perhaps this is evidence of rarity, that intelligence is vanishingly uncommon, and that most of the galaxy's story is written in stone, not in mind. Or perhaps it is evidence of subtlety, that civilizations hide their traces within the natural, leaving artifacts indistinguishable from debris. The silence may be less an absence than a camouflage. Astronomers now consider how best to confront this abundance. Future instruments, like the Vera C. Rubin Observatory, will survey the sky with unprecedented depth, expected to find dozens of interstellar objects each year. Space missions are being designed to intercept them directly, to chase them down and sample their surfaces. The European Space Agency's Comet Interceptor, for example, though not dedicated to interstellar bodies, could one day be redirected towards such a target. Other proposals envision fleets of nimble spacecraft, waiting like sentinels to pursue the next messenger as soon as it is detected. These efforts reflect a growing recognition. The study of interstellar objects is no longer peripheral. It is central to understanding the galaxy. Each detection, each sample, is a glimpse into worlds humanity will never visit directly. And within quadrillions, the chance of finding the extraordinary grows. Even if only 1 in a trillion were artificial, the galaxy could still be filled with thousands of artifacts. The difficulty is not their absence, it is their concealment among overwhelming abundance. The scale of abundance also inspires reflection on time. These objects endure for billions of years, long after the stars that birthed them have dimmed. They outlast civilizations, carrying with them the geological and chemical signatures of vanished systems. Some may even predate Earth itself, older than life, older than the Sun. In this sense, the interstellar current is a kind of archive, not of words or signals, but of fragments, a geological library drifting endlessly between stars, written not in language but in stone and ice. Perhaps civilizations too could write into this archive. A probe disguised as a comet would not need to survive forever. It would need only to join the current, and the current itself would ensure its dispersal. Over time, such artifacts could saturate the galaxy, waiting for recognition. Theories of abundance then reveal both promise and burden. Promise because the galaxy is more interconnected than ever imagined. Burden because the silence of civilizations becomes even more inexplicable against such richness. If quadrillions of fragments drift between stars, then absence is no longer a simple emptiness, it is a deeper mystery. A stillness that must be chosen, or concealed, or imposed by the forces unknown. Oumuamua, Borisov, Atlas. 3 points of light against an ocean. They are not anomalies. They are the first drops of a storm whose scale is only now becoming clear. The galaxy is not empty. It is abundant. It is saturated. It is alive with fragments of alien worlds, countless and ceaseless. The paradox is not that the galaxy is empty. The paradox is that amid such abundance, the voices of civilizations remain hidden. Life on Earth began in mystery, 4 billion years ago, on a young and turbulent world. Molecules assembled into something greater than chemistry. Proteins folded, RNA strands aligned, membranes enclosed, and from the lifeless emerged the living. But how this leap occurred remains unknown. Did it happen here, in Earth's primordial seas? Or was Earth seeded by something older, something carried from the stars? This is the question of panspermia, the idea that life does not always originate where it is found, but can travel between worlds, carried across cosmic distances by fragments of stone and ice. The hypothesis is not without foundation. Meteorites recovered on Earth have been found to contain amino acids, building blocks of proteins synthesized in the deep cold of space. On comets like 67Pa Churyumov-Gerasimenko, visited by the Rosetta mission, scientists have detected complex organic molecules, including glycine, a fundamental component of life's chemistry. Even in interstellar clouds, radio telescopes have observed molecules like formaldehyde and methanol, precursors to biology drifting between stars. The universe is not barren of organic potential, it is rich with it. If life's ingredients are scattered so widely, then the leap from chemistry to biology may not have happened only once. It may be a process seeded across the galaxy, catalyzed by comets and asteroids travelling between stars. Interstellar objects like 3I Atlas sharpen this possibility. Unlike asteroids bound to the Sun, these visitors come from systems far beyond. They are fragments of alien worlds, born in the disks of other stars, exiled by the gravity of giant planets and set adrift in interstellar space. Protected by layers of ice, shielded from radiation by rock, they may carry with them the dormant seeds of biology. Some experiments support this resilience. Microbes on Earth have survived exposure to the vacuum of space. Bacterial spores can endure intense radiation when sheltered within rock. On the International Space Station tardigrades, tiny creatures of extraordinary durability, have survived years of exposure to cosmic conditions. If such life can persist here, then perhaps it could survive the long exile of interstellar drift. The distances are immense, but time is longer still. A fragment cast from its parent system may wander for millions, even billions of years. And if even a fraction of such fragments carried viable microbes or prebiotic molecules, then the galaxy itself becomes a network of exchange, a quiet biological web linking worlds. This vision is both beautiful and humbling. It suggests that life may not be confined to isolated oases. It may be a galactic phenomenon, spread not by intention, but by nature's own currents. Planets may not be separate experiments, but interconnected chapters of the same story. If panspermia is real, then the silence of the Fermi paradox changes its meaning. Civilizations may be rare, but life itself may be common, sprouting across countless worlds seeded by the interstellar current. Perhaps many planets bloom with microbes, with forests, with oceans alive with creatures. But intelligence, the capacity to build civilizations, may remain the exception. In this way, life could be abundant, yet voices remain few. But there is also a more speculative interpretation. Perhaps panspermia is not only natural, but sometimes intentional. Civilizations may one day learn to seed life deliberately, launching probes designed to carry microbes across the galaxy, or encoding information within durable artifacts disguised as comets. Such efforts would be indistinguishable at first glance from natural fragments. To discover them would require more than detection, it would require recognition. This idea has echoes in human imagination. Some scientists have proposed that the earliest signs of alien civilizations may not be signals, but biology itself, life seeded purposefully across the stars. If so, then every interstellar visitor carries with it a possibility, however faint, that within its frozen heart lies not only chemistry but design. The scientific study of panspermia remains cautious. No interstellar object has yet been sampled directly. The evidence lies in probabilities, in the resilience of microbes, in the ubiquity of organic molecules in space. Skeptics argue that the harsh radiation of interstellar space would sterilize life long before it reached another system. Supporters counter that large fragments, shielded by kilometers of rock or ice, could protect life long enough to survive the journey. What remains certain is that the galaxy is not a closed system. Matter moves between stars, organic chemistry flourishes in space, and the building blocks of life are not unique to Earth. The panspermia question therefore remains open, poised between science and philosophy. If life here began with help from beyond, then Earth is not an isolated origin, but a continuation. Humanity itself may carry within its cells a legacy of distant stars. To look into the mirror of biology may be to look into the history of the galaxy. And if life can spread this way, then the silence of civilizations may be less absolute than it seems. Perhaps intelligence is not seeded as easily as biology. Perhaps the galaxy is full of living worlds, but only a few climb the ladder to thought. In this view, silence is not absence, but rarity. Life abounds, but civilizations flicker. Objects like Atlas embody this possibility. They drift silently, faint points of light across the sky. To astronomers, they are fragments of alien systems, but to philosophy, they are messengers of possibility. Each one may carry the seeds of life scattered across the galaxy like pollen on the wind. And so, as Atlas fades into the dark, the question lingers: was it only a comet, a shard of ice and dust? Or was it also a vessel carrying within it the ancient chemistry of biology, perhaps even the dormant seeds of life itself? The answer remains hidden. But the question itself reshapes our understanding of existence. Life may not be bound to Earth. It may be woven into the very fabric of the galaxy. The panspermia question does not end the Fermi paradox, it deepens it. For if life is common, the absence of civilizations becomes more profound. But it also offers hope. It suggests that Earth is not an accident, but part of a greater story. That life is not rare, but resilient. That even in silence, the galaxy may be alive, and among its countless fragments, drifting endlessly between stars, the seeds of that life may already be passing by. The silence of the galaxy presses like a weight. It is not the silence of emptiness, for the universe is alive with stars, with planets, with fragments of alien systems drifting through the dark. It is not the silence of stillness, for matter moves ceaselessly in cosmic currents, crossing gulfs of space. It is the silence of civilizations, a silence that feels unnatural. Why, in a galaxy so abundant, are there no voices, no beacons, no signs of enduring presence? One answer is absence. Civilizations may never arise, or may be vanishingly rare. Another answer is concealment. Civilizations may choose silence, hiding themselves deliberately. But there is a darker answer still: annihilation. The possibility that civilizations do arise but are destroyed before their signals can spread across the stars. Physics itself offers a chilling framework for such destruction: the idea of the false vacuum. In quantum field theory, the universe is thought to exist in a state of energy called a vacuum. But what if the vacuum we inhabit is not the most stable state? What if it is only metastable? A false vacuum, balanced precariously, destined eventually to collapse into a truer, lower energy state. If such a collapse were to occur, it would begin at some point in space, a quantum event expanding outward at the speed of light. Everything it touched would be annihilated, rewritten in an instant. No warning, no defense. The universe as we know it would vanish into a different set of physical laws, alien and unrecognizable. It is speculation, yes, but rooted in real mathematics. Particle physics allows for such a possibility, and if true, it means that civilizations may never endure long enough to broadcast across the stars. They may simply vanish, erased not by war or by time, but by the very fabric of reality. Other forms of annihilation need not be so absolute. Civilizations may destroy themselves through their own creations, technologies turned catastrophic, environments consumed, wars escalating beyond survival. They may fall not to cosmic inevitability, but to their own fragility. In this vision, the Great Silence is not the absence of civilizations, but the evidence of their impermanence. The galaxy may be full of beginnings, but nearly empty of continuations. Civilizations may rise like sparks, bright but brief, extinguished before their light can spread. What then of the interstellar visitors? Could Oumuamua, Borisov and Atlas be more than fragments of worlds? Could they be relics of destruction, shards cast outward by the collapse of systems, remnants of planets lost to catastrophe? A collision of worlds can eject debris into space, fragments that wander for millions of years. A dying star can scatter the remains of its system outward, flinging asteroids into exile. In the wreckage of civilizations too, fragments may endure. Machines may be left behind, broken or silent, drifting like tombstones across the galaxy. If the silence is annihilation, then perhaps these visitors are not only messengers of creation, but memorials of destruction. Carriers of absence, tokens of civilizations that never lasted. The fear deepens when considered in the context of time. The universe is ancient, 13.8 billion years old. Civilizations could have arisen billions of years before Earth itself formed. If they were destroyed, there would be no trace but fragments. The current of interstellar debris may therefore be more than a geologic archive. It may be an archaeology of extinction. Every shard of stone, every icy body, may carry within it the history of a system that is gone, some destroyed by stellar death, some consumed by instability, some perhaps extinguished by their own creations. The galaxy may be haunted not by living voices, but by the quiet debris of vanished ones. For humanity, this possibility is more than scientific, it is existential. If a civilizations cannot endure, then what hope does Earth hold? If silence is the echo of destruction, then the paradox becomes a warning. The absence of signals may not mean that others never lived. It may mean that they did not survive. Physicist Enrico Fermi's question, "Where is everybody?" may therefore carry within it a darker answer. They were here, but they are gone. And yet, in the presence of fear, there is also reflection. Annihilation is not proven. It is only one possibility among many, but its weight lies in the way it reshapes perception of the interstellar messengers. To see Atlas is to see not only a comet from a distant star, but also the possibility that it is a relic of catastrophe. To see Borisov is to imagine a fragment from a system that may no longer exist. To see Oumuamua is to wonder if its strangeness is the scar of a history erased. Every interstellar visitor becomes not only a messenger, but a question. A reminder that civilizations may not be eternal, and that survival is not guaranteed. The existential fears are sharpened by the fragility of Earth itself. Humanity too lives under threats, some cosmic, some of its own making. Asteroid impacts, supernovae, gamma-ray bursts, climate change, nuclear war, uncontrolled technology. To reflect on the great silence is to see in it a mirror, a possible future. The false vacuum may never collapse. Civilizations may never fall to physics itself, but they may fall to the same fragility that silenced the galaxy before. In this way, the interstellar visitors become more than astronomical curiosities. They become omens, not of certain destruction, but of possible fate. They remind humanity that it is not only a witness to the paradox, but a participant within it. The silence of the galaxy may one day include Earth, unless survival is learned. The darkness of this vision need not be final. To face existential fear is also to recognize possibility. If silence is annihilation, then survival becomes the rarest of achievements. And perhaps that is why the galaxy is so quiet, not because civilizations never rise, but because survival is extraordinary. If humanity can endure, then it may be among the rare voices to speak against the silence. For now, the fragments drift, some natural, some perhaps relics, all wrapped in ambiguity. They are reminders of both creation and destruction. They are the silent witnesses to a galaxy that may have been filled with sparks, each extinguished before its flame could spread. The great silence may therefore not be absence, but memory, a memory written in stone and ice, carried by interstellar messengers that pass briefly through the solar system before vanishing back into the dark. Each one leaves behind the same haunting reflection. Perhaps civilizations did exist. Perhaps they seeded the galaxy with fragments. Perhaps all that remains of them now drifts quietly past, unnoticed. And perhaps the silence of the stars is not because nobody was ever there, but because in the end, nothing endures forever. Archaeology on Earth is the study of fragments, shards of pottery, broken tools, ruins buried in dust. From remnants, entire civilizations are reconstructed. From traces, the lives of the forgotten are restored. What humanity cannot see directly, it learns from what endures. In the cosmos, the same principle unfolds on a grander stage. But here, the artifacts are not clay pots or stone carvings. They are worlds shattered, comets exiled, asteroids cast adrift. Interstellar objects are the fossils of planetary systems. They are fragments of histories written in rock and ice, drifting between stars like relics of alien epochs. To study them is to practice cosmic archaeology. Consider Borisov, the interstellar comet of 2019. Its chemistry revealed a world colder than most comets in the solar system. Perhaps born around a dim red star, its nucleus rich in carbon monoxide. From this single shard, astronomers glimpsed the conditions of a system light years away, a system never seen but revealed in a fragment. Consider Oumuamua, whose shape and the unexplained acceleration defy easy classification. Its very strangeness is a clue, suggesting processes unknown or environments alien to our own. It is as though a tool of mysterious design were unearthed at an archaeological dig, its purpose lost to time, its maker unseen, but its existence undeniable. And now, Atlas, dim and fleeting, another shard with its own signature. Not as strange as Oumuamua, not as flamboyant as Borisov, but still unique, a page torn from a story written around another sun. Each interstellar object is a relic of a distant past. Some may be the remains of planetesimals never incorporated into worlds. Others may be the debris of collisions, fragments flung outward by violence. Still others may be the ejected comets of giant planets, banished to eternal exile. Together, they are a record of processes universal and diverse. From them, astronomers reconstruct the unseen. Just as the shards of an amphora tell of trade and culture, so do these fragments tell of planetary birth and deaths. They are the ruins of star systems, preserved in silence, wandering endlessly. The tools of cosmic archaeology are telescopes and spectra, not brushes and trowels. By measuring how an object reflects light, scientists deduce its composition. By tracing its orbit, they reveal its origin. By studying its activity, they glimpse its chemistry. Each photon gathered is like a grain of soil sifted, revealing hints of a world never touched. But unlike terrestrial archaeology, the fragments cannot be held. They pass too quickly, too faintly, vanishing into the dark before full understanding can be reached. The cosmic archaeologist works with incomplete evidence, piecing together mysteries from glimpses, constructing histories from silence. The implications are profound. If the galaxy is filled with quadrillions of interstellar objects, then it is filled with the debris of planetary systems. Each star may contribute countless fragments, each fragment a fossil. Together, they form a galactic archive. To study them is to read the lost histories of stars, the forgotten geology of planets, the echoes of systems that may no longer exist. Some of these fragments may outlast their parent stars. When suns burn out, when planets are consumed, when civilizations fall, the debris remains. Cast outward, it drifts for billions of years, carrying memory beyond the death of its source. In this way, interstellar objects are not only fossils, but immortals, outliving the worlds that gave them birth. This transforms the Fermi paradox into a new kind of search. If civilizations once existed but have perished, their ruins may not be detectable in light or radio. But their fragments may still drift. Not cities, but stones. Not signals, but or fossils. Perhaps even artifacts, engineered but disguised as natural. Cosmic archaeology may therefore extend beyond geology into the possibility of technology. To find an interstellar object that reveals artificial design would be to uncover the first artifact of alien intelligence. A discovery not of the present, but of the past. The interstellar current may carry not only the fossils of planets, but the ruins of civilizations. This perspective reframes the visitors not as anomalies, but as opportunities. Each one is a chance to practice archaeology on a galactic scale. To intercept them, to study their surfaces, to drill into their ice, is to excavate the history of another system. Already, missions are being imagined, spacecraft that wait in readiness, poised to launch when the next interstellar object is detected. A cosmic excavation not on Earth, but in space. The dream is to one day hold in human hands a fragment of another star's history. A fossil not of Earth, but of the galaxy. Philosophically, this is transformative. On Earth, archaeology binds humanity to its past, reminding it of its continuity. In the galaxy, cosmic archaeology binds humanity to the stars, reminding it that it is part of a greater story. Earth is not the first world to shape matter, nor will it be the last to leave fragments drifting in space. Humanity itself may one day contribute to this archive, whether by accident or intention. Its satellites, its probes, its debris may wander long after humanity itself is gone. One day, another intelligence may practice cosmic archaeology on the relics of Earth. The interstellar visitors are not only scientific discoveries, they are mirrors. They show humanity not only the diversity of other systems, but the fragility of its own. They remind us that all worlds, all civilizations leave behind fragments, that permanence is not guaranteed, but remnants endure. To call them fossils is to acknowledge their dual nature. They are silent, lifeless, inert. Yet they are also storytellers. They carry within them the memory of systems unseen, civilizations unknown, stars perhaps long extinguished. They drift through the solar system like artifacts displayed for a moment before vanishing back into the dark. Each one is a museum piece in motion. Each one is a question disguised as stone. Cosmic archaeology is still in its infancy. Humanity has glimpsed only 3 interstellar fossils, each fleeting, each incomplete. But even in these beginnings, the promise is immense, for every fragment is a key to a history never otherwise accessible. To study them is to expand the boundaries of archaeology from Earth to the galaxy. And perhaps, within this work, lies the answer to the Fermi paradox. Perhaps the silence of civilizations is not the silence of absence, but the silence of fossils. Traces scattered, waiting to be recognized. Civilizations may not endure, but their remnants may. And in the interstellar current, those remnants drift endlessly. The galaxy is not empty. It is a graveyard and a library, filled with fossils of worlds. To see an interstellar object is to glimpse one of these fossils, to practice the archaeology of the cosmos. And in this archaeology lies both knowledge and warning that all civilizations, even our own, may one day be reduced to fragments drifting between stars. For most of human history, interstellar visitors passed unseen. Shards of alien systems slipped silently into and out of the solar system, their paths unmarked, their stories unread. It was only in the past decade that vigilance sharpened, and the first three were glimpsed. Oumuamua, Borisov, Atlas. Drasijarivfell revealed a truth already present. The galaxy is threaded with wanderers, and Earth is immersed in their current. But the questions they raise cannot be answered with fleeting glimpses. To understand these messengers, humanity must learn not only to notice them, but to study them in detail. This demands new instruments, telescopes to detect, observatories to analyze, missions to pursue. The tools of investigation must rise to meet the mystery. The most transformative of these tools is the Virasi-Rubin Observatory, rising in the Chilean Andes. With its vast mirror and its wide-field legacy survey of space and time LSST, it will photograph the entire southern sky every few nights, creating a moving portrait of the heavens. In its relentless cadence, Rubin will catch the faint motions of countless small bodies, asteroids, comets, and among them, interstellar visitors. Where past surveys caught one object by chance, Rubin may find dozens each year. Its data will reveal not only the rare and strange, but the statistical truth of the interstellar current. How many fragments drift through the solar system? How varied are their forms? How common are anomalies? The Rubin Observatory will not merely detect, it will count, classify, and map the unseen tide of alien debris. But detection is only the first step. To unravel their nature, light itself must be dissected. Here, the James Webb Space Telescope offers power unmatched. Though not designed to chase moving targets, its infrared vision can, when aligned, probe the chemistry of faint visitors. By splitting their light into spectra, Webb can reveal the molecules frozen into their surfaces: water, carbon monoxide, methane, cyanide. In these signatures lies the fingerprint of alien birthplaces. With Webb, humanity may glimpse not only the chemistry of one world, but the diversity of many. Each interstellar object is a page torn from another planetary system's story. Through their spectra, Webb can help translate those stories into knowledge. Yet even the finest telescope cannot replace proximity. To truly study an interstellar visitor requires encounter. A mission must not only observe from afar, but travel, intercept, and sample. Here lies the promise of spacecraft. The European Space Agency's Comet Interceptor, scheduled for launch later this decade, is designed to wait in space until a new target is discovered. While its primary aim is a fresh comet from the Oort cloud, its design could, in principle, be redirected to an interstellar object. Agile, ready, patient. It is a model of how humanity may one day pursue the next messenger. Other proposals reach further. NASA scientists have envisioned interceptor fleets, swarms of small spacecraft stationed across the solar system. When an interstellar visitor is detected, one could be dispatched at once, riding high-speed trajectories to intercept. In this vision, Earth's telescopes become sentinels, and its spacecraft become hunters, ready to chase the fleeting travelers before they vanish. More ambitious still is the idea of a dedicated interstellar probe, a mission designed not merely to encounter but to follow, embedding itself alongside a visitor, studying its form, its chemistry, even drilling into its surface. Such a mission would be humanity's first direct excavation of a fragment born beyond the sun, the first true act of cosmic archaeology. The scale of these efforts reveals more than scientific curiosity. It reveals urgency, for interstellar objects do not wait. They pass swiftly, fading within months, never to return. Each detection is an opportunity that closes quickly, a window that will never open again. To study them is to race against time itself. This urgency drives collaboration. Ground-based telescopes coordinate with space observatories, data is shared across continents, missions are designed in anticipation of chance. In the fleeting light of a visitor, humanity glimpses not only alien worlds, but also the necessity of vigilance. Philosophically, these tools are more than instruments, they are extensions of perception. The Rubin Observatory expands the human eye across the entire sky, seeing motion too faint for any one gaze. The James Webb Space Telescope extends vision into the infrared, reading molecules invisible to ordinary light. Interceptor spacecraft extend touch itself, reaching across space to hold fragments never meant to be held. Together, they transform humanity from passive witness to active participant in the interstellar current. The galaxy flows through the solar system, and with these tools, humanity learns not only to notice but to listen, to touch, to interpret. The promise of this investigation is immense. Each visitor studied is a world revealed. Each fragment sampled is a story translated. The chemistry of Borisov already told of a star colder than the sun. The strangeness of Oumuamua hinted at processes still unknown. The ambiguity of Atlas invites speculation yet to be resolved. With better tools, such mysteries will multiply, and with them, understanding. And within this promise lies possibility. If some interstellar visitors are not natural at all, but artificial, then only through detailed study could this be known. Only by intercepting, sampling, or listening closely could such an artifact be recognized. In this way, the tools of investigation become not only scientific, but existential. They hold the potential to answer the Fermi paradox itself. Yet there is also humility in these tools. For all their power, they remain limited. Rubin will find many objects, but only the brighter and closer ones. Webb will read spectra, but only faintly, and only when timing allows. Missions may intercept, but only a handful among countless visitors. The current is vast and human tools are small. Still, each step is progress, each detection is knowledge, each mission is preparation. Over time, the archive of fragments will grow, and from it patterns will emerge. The archaeology of the galaxy will shift from speculation to science. To build such tools is to confront both wonder and fear. Wonder because they allow glimpses into alien systems. Fear because they may reveal truths humanity is not ready to face, that civilizations do not endure, or that artifacts of intelligence drift unnoticed among debris. The tools cannot choose what they uncover, they can only reveal. And so, as the Rubin Observatory prepares to open its eye, as Webb continues its silent watch, as interceptors wait in orbit, humanity stands at the threshold of a new age of discovery, the age of interstellar archaeology, the age of listening not only to light, but to matter itself. For the galaxy is not silent. It speaks through fragments, drifting endlessly between stars. And with these tools, humanity may finally learn to hear. Astronomy is a science of light. Every image, every spectrum, every orbit traced through the night sky comes from photons that have travelled across vast distances before striking a mirror or a detector. Yet even with the greatest of instruments, the universe reveals itself only in fragments. What is seen is always less than what exists. Nowhere is this more evident than in the study of interstellar visitors. Oumuamua, Borisov, and Atlas were visible only because chance aligned their paths with human vigilance. Each was faint, each moved quickly, each faded within months. For every visitor detected, there may be thousands, perhaps millions, slipping past unseen. The current of interstellar objects is vast, but our gaze is narrow. The limits begin with detection. Telescopes like Pan-STARRS and Atlas survey the sky for near-Earth asteroids, but their reach is finite. They cannot scan every region every night, nor can they peer deeply enough to catch the smallest and faintest wanderers. Even the Vera Rubin Observatory, with its sweeping surveys, will still miss countless objects too dim or too distant. Most interstellar fragments are likely no larger than boulders or pebbles. These pass through the solar system invisibly, burning as meteors in Earth's atmosphere or vanishing into the dark without ever being noticed. Only the rare kilometre-scale bodies shine brightly enough for telescopes to find. Humanity sees only the giants, never the multitude of smaller messengers. There are also limits of interpretation. Oumuamua's unexplained acceleration may have been caused by sublimating hydrogen or nitrogen ice, but the evidence was too faint to confirm. Borisov's chemistry hinted at a cold alien birthplace, but its details blurred in distance. Atlas flickered briefly before fading, leaving ambiguity unresolved. In each case, the dataset was thin, incomplete. mere glimpses of a story already vanishing. Science thrives on accumulation, on repeated measurements, but interstellar visitors are fleeting. They grant only days or weeks of clarity before receding into invisibility. Each one is a page glimpsed in passing, never the full book. There are limits too of proximity. No mission has yet intercepted such an object. All knowledge so far comes from telescopes on Earth or in orbit, watching from afar. Without a spacecraft to sample, to touch, to drill into their cores, understanding will remain partial. The difference is like studying a fossil through binoculars instead of holding it in hand. And yet missions take years to prepare, while interstellar visitors offer only months of warning. Until humanity develops interceptors that wait in readiness, most visitors will escape unexamined. They will pass through the solar system like phantoms, never revealing their secrets. The greatest limit, however, may be philosophical. Humans interpret anomalies through the lens of what is already known. A strange acceleration is explained by hidden gases. A red hue is attributed to cosmic radiation. A faint signal is dismissed as noise. In caution, the extraordinary is often folded back into the ordinary. This protects science from error, but it may also blind it to possibilities. If even one visitor is more than natural, if it is artifact, not accident, then the limits of perception may prevent recognition. The paradox of silence may be less about absence and more about blindness. What escapes the gaze may hold the answers. Among the unseen multitude, there may be objects bearing the building blocks of life, fragments seeded with amino acids or even dormant microbes. Among the faint and unstudied, there may be shards from civilizations long gone, artifacts mistaken for stone. Humanity cannot know because humanity cannot yet see. The galaxy does not lack messengers. It overflows with them. What it lacks is the capacity to listen. The limits of knowledge are not foes or failure. They are the horizon of progress. They define where science must grow, where instruments must sharpen, where imagination must expand. The Rubin Observatory will broaden the field of vision. The James Webb Space Telescope will sharpen the chemistry of faint light. Interceptor missions may one day bridge the gulf of distance. Yet even these will see only fragments of the whole. The interstellar current is too vast to be fully measured, too abundant to be fully catalogued. Humanity will always see less than what is, but within what is seen, meaning may still emerge. Patterns may still reveal themselves. A single anomalous fragment may still change everything. The paradox remains unresolved, and perhaps it always will. The galaxy may never yield a full accounting of its civilizations, its life, its ruins. But within the limits of knowledge, there is still wonder. To glimpse even 3 interstellar visitors is to know that the universe is richer than silence, more dynamic than isolation. To stand at the boundary of understanding is to feel the weight of possibility. The limits of knowledge are not the end. They are the beginning of questions yet unasked, discoveries yet unseen, and as countless visitors pass unseen through the solar system, humanity waits, watching, listening, building better eyes to pierce the dark. For among what escapes the gaze, the answers to the paradox may already drift. The cosmos moves on timescales almost beyond imagination. Stars live for billions of years. Planets endure for eons. Galaxies rotate like slow whirlpools, their arms sweeping through space in revolutions that last hundreds of millions of years. Against such immensity, a human lifetime is less than a flicker. Even the span of civilization is but a heartbeat. And yet, within the briefest instant of human history, 3 extraordinary events have unfolded. In 2017, Oumuamua was detected, the first recognized interstellar object. In 2019 came Borisov, a comet from beyond the Sun. In 2024 arrived Atlas, the 3rd interstellar visitor. 3 detections in only 7 years. For a species that has watched the sky seriously for just a century, the improbability is staggering. It is as though 3 messages from the stars arrived at once, after billions of years of silence. Before Oumuamua, astronomers expected such visitors to be rare beyond imagining. To find one might take centuries. Some predicted humanity would never see one at all. The void between stars was thought too wide, the fragments too faint, the chances of encounter too slim, and yet 3 arrived almost together. Not on cosmic scales of time, but on human scales, within the span of a single generation. The odds defy expectation. Coincidence alone seems insufficient. The explanation lies partly in progress. Humanity's instruments have sharpened. Wide-field surveys like Pan-STARRS and Atlas have expanded vigilance. Algorithms now sift millions of points of light for motion too subtle for the human eye. And in the near future, the Vera C. Rubin Observatory will turn night into a tapestry of data, sweeping the heavens with unmatched depth and cadence. These tools reveal what was always there, hidden in plain sight. Interstellar visitors are not rare. Humanity was simply blind until recently. The apparent coincidence is the result of a threshold crossed, an awakening of perception. But the coincidence still carries weight, for what is revealed is not only abundance but immediacy. The interstellar current is not a distant abstraction. It is here, now, flowing through the solar system. Humanity is not separate from the galaxy, but immersed in it. To detect three in such rapid succession is to glimpse the scale of the hidden tide. For every one found, countless more pass unseen. The galaxy may contain quadrillions of such objects, each a fragment of alien history, each a possible carrier of life or artifact of civilization. The discoveries suggest that Earth drifts not through turbulence, but through a storm of fragments. The improbability of coincidence becomes the inevitability of abundance. This escalation may mark the threshold of a new era in science. The study of exoplanets once seemed impossible. Now thousands are known. The study of interstellar objects once seemed unimaginable. Now 3 have been glimpsed in less than a decade. Soon, with sharper eyes, dozens may be catalogued each year. Humanity may be standing at the dawn of interstellar archaeology, a discipline not of distant starlight alone, but of tangible fragments drifting into reach. Each detection is not only discovery, but invitation. Each object is a chance to examine directly the geology, chemistry, and perhaps biology of alien systems. And if some are not natural but artificial, then this era may bring more than archaeology. It may bring recognition. The improbability of coincidence also resonates with philosophy. To live at this moment, when the veil is lifting, is to stand at a unique boundary in time. For billions of years, the interstellar current flowed unnoticed. For billions more, it may continue after humanity is gone. But within this narrow oasis window, a species of fragile beings on a small world has begun to notice. The tide has always been there. The change is not in the cosmos, it is in perception. Perhaps this is how revelation arrives, not with a single overwhelming signal, but with a series of small events, each one deepening awareness, until the pattern becomes undeniable. And still, questions remain. Is this truly coincidence, or is there deeper meaning? Are we simply opening our eyes at last, or are we being shown something deliberately? Are these 3 visitors only fragments of geology, or are they also messages hidden in matter? The science is cautious. It speaks of surveys, probabilities, detection thresholds, but philosophy hears whispers that perhaps the timing is not only chance but significance, that perhaps the paradox of silence is beginning to unravel, not in signals from the sky, but in stones that drift quietly past. Escalation brings urgency. To see 3 in such a short span is to know that opportunities are passing constantly. Each visitor is fleeting, each vanishes into the dark. Without readiness, without tools to intercept, most will be lost. This urgency is why astronomers speak of interstellar intercept missions, of spacecraft that wait in orbit to chase the next arrival. The coincidence of 3 visitors has transformed speculation into necessity. Humanity knows now that the visitors will come again and again and again. The only question is whether we will be prepared. The improbability of coincidence is not improbability at all. It is revelation. It is the threshold between blindness and sight, between silence and subtle presence. 3 visitors in 7 years are not anomalies, but heralds. They announce that the galaxy is alive with motion, that fragments of other stars drift constantly into reach, and that humanity has only just begun to notice. The escalation is not the end of the paradox, it is its intensification. For amid such abundance, silence is harder to explain. The galaxy is full of messengers, yet none carry unambiguous voices. The paradox sharpens, and with it, the need to look deeper. Perhaps the next visitor will be ordinary. Perhaps it will be another comet, icy and bright. Or perhaps it will be strange like Oumuamua, accelerating for reasons unknown. Or perhaps it will be extraordinary, an artifact disguised as stone the first undeniable proof of minds beyond Earth. Coincidence or inevitability, the escalation ensures one truth. The interstellar current is real, and humanity is standing at the threshold of a new chapter. The question is no longer whether the messengers will come. The question is whether we will be ready to hear what they carry. The silence of the stars is vast. Too vast, some would argue, to be explained only by probability or chance. A galaxy filled with planets, with interstellar debris, with the restless exchange of matter, and yet no voices, no signals, no undeniable artifacts. The contradiction drives thought toward horizons stranger still, to possibilities that stretch beyond the fabric of this universe itself. Among these horizons lies the multiverse hypothesis, the idea that our cosmos is not singular, but one of many. An infinity of universes, each with its own laws, its own histories, its own outcomes. If the multiverse exists, then the silence may not be emptiness. It may be the result of partition. Civilization may bloom in countless universes, but not here. Or it may bloom here, but separated by walls impenetrable, forever beyond reach. Humanity may live in a universe where the probability of contact is simply vanishingly rare, a universe tuned for life to arise, but not for civilizations to meet. The roots of this speculation lie in physics. In the theory of cosmic inflation, our universe expanded from a quantum seed, ballooning faster than the speed of light in its first fractions of a second. Some models suggest that inflation never stopped. It continues elsewhere, spawning other universes beyond the reach of ours. An endless multiverse, each bubble isolated, each sealed within its own laws. Quantum mechanics offers another vision. In the many worlds interpretation, every possible outcome of every quantum event branches into a new universe. Infinite variations, infinite histories, infinite civilizations, yet none aware of the others. Silence, not because life is rare, but because it is partitioned by the very fabric of reality. Against this backdrop, interstellar objects take on an almost metaphysical weight. They are not only fragments of alien systems, they are reminders that exchange within a single universe is possible. Matter drifts freely between stars, and yet no voices are carried with it. This silence feels sharper when placed against the multiverse. What if voices do exist, but not here? What if civilizations thrive in neighboring universes, their presence forever sealed from us? In this vision, interstellar visitors become symbols of both connection and isolation. They cross the gulfs between stars, bridging solar systems separated by light years. But they cannot cross the deeper gulf, the boundary between universes. They remind humanity that even within abundance there are divides that may never be crossed. Some speculate further. If universes do branch infinitely, might there exist rare pathways where boundaries blur? Could exotic phenomena, black holes, quantum tunnels, cosmic strings, permit fragments of matter to slip across divides? If so, then interstellar objects might be more than wanderers of this universe. They might be visitors from others, fossils not only of alien stars but of alien realities. This remains speculative in the extreme. No evidence confirms it, and physics offers more caution than invitation. Yet the thought is haunting. If the silence of civilizations is because most universes are empty of them, then to live in one of the few where life exists at all is both miracle and isolation. Philosophically, the multiverse speculation deepens the paradox. It suggests that the silence may be permanent. No amount of searching, no number of telescopes, no intercept missions could overcome a divide written into the structure of existence. Civilizations may exist in abundance, but their voices will never cross into ours. The interstellar current then becomes a consolation. Within this universe, matter still moves, fragments still flow, connection still happens, even if it is only between stars and not between universes. Humanity may never speak to neighbors across the multiverse, but it can still learn from the fossils that drift within its own cosmic sea. This perspective carries both melancholy and wonder. Melancholy because it suggests a loneliness deeper than the galaxy, an isolation written into the nature of reality. Wonder because it reframes even the smallest interstellar visitor as extraordinary. If communication across universes is impossible, then every shard from another star is a treasure. Every fragment that drifts into the solar system is part of the only archive accessible, the only bridge across cosmic divides humanity may ever cross. The multiverse speculation also reframes survival. If universes branch infinitely, then in some, civilizations endure. In others, they fall. In ours, the outcome remains unwritten. The paradox of silence may not be universal at all, but local, a feature of this particular reality. And within it, humanity must write its own story. Perhaps this is the lesson of the interstellar visitors. They remind us that even within one universe, fragments can cross gulfs once thought unbridgeable. Stars separated by light years can still exchange matter. If this is possible here, then perhaps within the boundaries of our universe, civilizations too may yet connect. The silence may be vast, but it may not be final. Science cannot yet prove the multiverse. It remains speculation, a possibility glimpsed through mathematics and imagination. But it serves a purpose. It widens perspective. It reminds humanity that silence may have causes more profound than absence, more fundamental than probability. That the mystery of the paradox may not only be about life, but about the fabric of reality itself. In this way, interstellar objects become symbols of what is possible. They are not bridges across universes, but they are bridges across stars. They remind us that connection is real, even within limits. They whisper that while the multiverse may remain unreachable, this universe still offers communion, through fragments, through fossils, through messengers of stone and ice. The multiverse speculation does not answer the paradox, it deepens it, but it also sharpens appreciation of the moment. To live in a universe where interstellar visitors are seen, where fragments of alien systems drift into reach, is to live in a reality already filled with wonder. Silence may persist, but silence does not mean emptiness. Perhaps contact with other universes will never come. Perhaps civilizations elsewhere will remain forever beyond. But here, in this universe, in this galaxy, in this moment, the interstellar current flows, and within it, humanity has begun to listen. For more than 70 years, the Fermi paradox has been framed as a contradiction. The galaxy should be alive with civilizations, and yet it appears silent. Enrico Fermi's question, "Where is everybody?" has echoed through science and philosophy as both riddle and challenge. The absence of evidence has often been taken as evidence of absence. But perhaps the paradox itself is misinterpreted. Perhaps the contradiction is not between probability and silence, but between expectation and perception. Humanity listens for radio signals, looks for megastructures, searches for the unmistakable fingerprints of technology, and yet civilizations, if they exist, may not choose to speak in those ways. Their presence may be hidden in subtler forms, embedded not in light or sound, but in matter. The interstellar visitors, Oumuamua, Borisov, Atlas, offer a lens through which to reconsider. They are evidence that the galaxy is not a closed system. They prove that stars exchange fragments. They reveal that Earth is immersed in a current of alien matter, washed constantly by the debris of other systems. If civilizations arise, their traces may already be drifting here, not as signals across the void, but as artifacts lost among the tide of stone and ice. Reconsideration begins with humility. The assumption that intelligence must announce itself may be a projection of human desire for contact. But what if survival favours silence? What if civilizations choose not to broadcast or evolve beyond the need? The paradox then dissolves. There is no contradiction, only misaligned expectation. Fragments may already be here. They may fall into the atmosphere as meteors, scatter into oceans, or pass unnoticed into the dark. Some may carry only geology, the inert remnants of planetary formation. Others may carry biology, the building blocks of life, seeds of panspermia. And a rare few may carry intention, the artifacts of civilizations that chose endurance over communication. In this light, the paradox is not absence but camouflage. Civilizations may not speak in voices humanity recognizes, but their presence may still be written into the material record of the galaxy. Astronomy has already seen hints of this broader interpretation. Meteorites found on Earth carry amino acids forged in interstellar space. Comets studied by spacecraft have revealed organic molecules, precursors to biology, drifting in the cold. Radio telescopes have detected complex chemistry in molecular clouds, proving that the ingredients of life are scattered abundantly. These are not signals in the traditional sense, but they are evidence of a universe already predisposed toward life. When viewed through this lens, interstellar debris becomes more than rock. It becomes message. not in words, but in presence. Each fragment testifies that systems beyond the sun exist, that they are fertile in matter, that exchange is constant. To mistake this for silence is to misunderstand the language of the cosmos. Reconsideration also requires patience. Civilizations, if they endure, may not measure time in centuries, but in millennia or millions of years. A probe drifting silently among interstellar debris may be designed not for immediate recognition, but for eventual discovery, waiting for a species to reach the capacity to notice. To us, the galaxy may appear mute, but to them, communication may already be happening, stretched across spans of time so vast that impatience blinds perception. From this perspective, the paradox is not a failure of the cosmos to reveal itself. It is a failure of humanity to yet understand how to listen. The galaxy may be speaking in fragments, in fossils, in subtle traces scattered through the interstellar current. The evidence may already be here, hidden not by distance but by expectation. This reconsideration reframes silence itself. What appears to be absence may be presence in unfamiliar form. The great silence may not be void, but whisper. Civilizations may not build beacons brighter than stars. They may scatter seeds. They may leave relics disguised as comets. They may allow matter itself to be the archive of their existence. If so, the paradox dissolves. There is no contradiction between abundance and silence. There is only the challenge of perception. To learn to read the archive of the galaxy not only in light, but in matter. Interstellar visitors embody this challenge. Oumuamua remains unexplained, its strange acceleration still debated. Borisov revealed chemistry beyond the solar system, a comet from a world unseen. Atlas, dim and ambiguous, whispered again of abundance. None of them carried clear signals, none of them announced themselves, and yet each was evidence of connection. Each was a fragment of a wider galactic story. Perhaps this is how civilizations reveal themselves, not in sudden revelations, but in subtle traces, not in words, but in presence, not in answers, but in questions that endure. Philosophically, to reconsider the paradox is to accept that contact may not be as imagined. The alien may not arrive in ships or in messages beamed across light years. It may arrive in stone. It may already have arrived unnoticed centuries ago. The paradox, then, is not unsolved, it is unrecognized. This realization is humbling. It suggests that humanity's role is not to wait passively for a message, but to become archaeologists of the cosmos, to treat each interstellar fragment as potential record, to search patiently, to build instruments capable of intercepting, to develop the imagination necessary to recognize what may not look like technology at all. The paradox may not be a contradiction to be solved, but a misunderstanding to be transcended. And so the silence of the stars remains, but no longer as emptiness. It becomes instead an invitation to listen differently, to look beyond expectation, to reconsider what evidence might mean. For civilizations may not speak, but their fragments drift. And within those fragments, the paradox may already hold its answer. The three known interstellar visitors, Oumuamua, Borisov, and Atlas, passed through the solar system like fleeting apparitions. Each was glimpsed only briefly, studied at a distance, then lost forever to the darkness. They came without warning, and by the time they were recognized for what they were, it was too late. Humanity could only watch them vanish, but the hunger to do more has already begun to reshape science. For the next time, astronomers and engineers do not want to merely watch. They want to chase. They want to touch. They want to hold in human hands a fragment from another star. This is the dream of interstellar interception missions. Spacecraft designed not to orbit planets or moons, but to pursue messengers that come unbidden, racing into and out of the solar system. The first steps toward this dream are already underway. The European Space Agency's Comet Interceptor, scheduled for launch in the late 2020s, is designed to wait in space for a target yet unknown. It will linger at a gravitational balancing point, ready to be dispatched toward a newly discovered comet or interstellar object. Its purpose is agility, to be prepared not for a specific destination, but for opportunity. Should another Borisov or Atlas appear, Comet Interceptor could become the first mission to meet it directly. NASA scientists have gone further, drafting plans for interstellar interceptors, fleets of small, fast spacecraft pre-positioned across the solar system. Like sentinels, they would wait in readiness. When telescopes detect the faint glow of an incoming object, one could be launched on a high-speed trajectory to rendezvous. Equipped with cameras, spectrometers, and dust collectors, such probes would allow humanity to study in detail a fragment from another star before it slips away. These concepts face immense challenges. Interstellar objects move quickly, tens of kilometers per second, faster than most spacecraft ever built. To intercept them requires either extraordinary speed or extraordinary foresight. Missions must be ready to launch within weeks of discovery, a tempo far swifter than traditional space exploration. Engineering, logistics, and politics must all bend to urgency. Yet urgency itself has become part of the dream. The fleeting nature of Oumuamua and Borisov revealed how much is lost by waiting. To do better, humanity must learn to anticipate. Other visions push beyond interception. Some propose missions not just to encounter, but to ride alongside interstellar visitors. By matching velocity, a spacecraft could drift with a fragment for months or years, studying its surface, probing its chemistry, even deploying drills to sample its interior. Such an mission would be nothing less than an archaeological excavation across space, the direct study of a fossil from another star. Ambition reaches further still. Some imagine capturing a small interstellar object, redirecting it into stable orbit near Earth, and studying it at leisure. The challenges of mass, speed, and energy are immense, but not inconceivable for a future of advanced propulsion. If achieved, humanity could place in its laboratories a relic from beyond the sun. The pursuit of these dreams is not only technical, it is philosophical. To touch another star's fragment is to collapse distance itself. Light from distant systems has always been studied indirectly as spectra on a telescope's detector. But a captured fragment is not light. It is matter, solid, tangible, enduring, a piece of another star system carried across the abyss, brought into human hands. The difference is profound. It would mark the first time humanity has held in its grasp not only the story of Earth, but the story of elsewhere. The missions also carry existential weight. If the Fermi paradox is to be addressed, if the silence of the stars is to be interpreted, then studying interstellar visitors is essential, for within them may lie the answers. They may carry organic molecules, proving panspermia is real. They may reveal strange chemistries, teaching us how alien systems evolve. And perhaps, though still only speculation, they may conceal artifacts of intelligence, relics of civilizations hidden among the debris. Without interception, these possibilities remain forever untested. With it, the silence may one day break. The dream of touching another star's fragment also reflects something deeper, humanity's own place in the current. For just as fragments drift into the solar system, so too has Earth cast fragments outward. Probes like Voyager 1 and 2, Pioneer 10 and 11, and New Horizons already travel between the stars. In time, they may pass through alien systems, becoming interstellar visitors themselves. To intercept a fragment from elsewhere is to glimpse what others might one day see of us. It is a mirror as much as a discovery. The path ahead is clear: vigilance, preparation, and readiness. The Vera C. Rubin Observatory will provide the vigilance, finding visitors with unprecedented frequency. Interceptor spacecraft will provide the readiness, chasing the fleeting before it vanishes. Together, they will transform the study of interstellar objects from chance to certainty, from fleeting glimpses to detailed exploration. And when the day comes, when the next messenger is intercepted, the boundary of science will shift. Humanity will no longer be confined to studying its own solar system. It will hold in its hands a fragment of another. This moment will not be an end, but a beginning. Each fragment studied will raise new questions. Each mission will reveal new anomalies. Each discovery will remind us of how much remains unseen, but it will also remind us that the galaxy is not silent, not empty, not still. It is alive with motion, with fragments, with possibilities waiting to be recognized. The dream of touching another star's fragment is no longer fantasy. It is plan, it is proposal, it is preparation. It is the next step in humanity's dialogue with the cosmos. For the visitors will come again. The question is whether this time we will reach out and meet them. In the deep stillness of night, when telescopes sweep the heavens, what they find are not voices, not signals, but fragments. Silent wanderers drifting through space. Each one carries with it a history that predates humanity, predates Earth itself, predates even the Sun. They are travelers older than civilizations, older than memory, fragments set adrift in the cosmic tide. To encounter them is to be reminded of scale. Stars live for billions of years. Planets form, flourish, and perish in ways that unfold slower than language can describe. Civilizations, by contrast, are fragile. Brief sparks, flaring for a few thousand years, vanishing before they can echo across the galaxy. Against such vastness, the silence of the stars becomes less surprising and more inevitable. The interstellar visitors, Oumuamua, Borisov, Atlas, are not voices. They are not declarations of presence. They are remnants, drifting without intent, fragments of processes vast and impersonal. And yet, in their silence, they are deeply poetic, for they are reminders of how fragile, how temporary, how precious civilizations truly are. To drift between stars is to be untethered from origin. Each object once belonged somewhere, to a disk of dust circling a young star, to a system where giant planets scattered debris outward, to a family of worlds that may or may not still exist. But time erases memory. Ejected into the abyss, these fragments wander for millions, even billions of years, stripped of context, reduced to pure motion. And yet, in their endurance, there is a quiet nobility. They survive where worlds do not. They endure where civilizations collapse. They are fossils of processes long gone, whispers of histories erased, testimony that nothing is truly lost, only transformed into drift. This cosmic drift is haunting because it mirrors the fate of civilizations themselves. What will remain of humanity after its brief spark has faded? Perhaps not monuments or signals, perhaps only fragments, spacecraft like Voyager, cast outward into interstellar space carrying a golden record of sounds and images, drifting without destination. Perhaps debris from uncertain satellites, broken and scattered, drifting for ages in silence. Humanity, too, will leave its fragments in the current, and perhaps they will endure long after its voice has vanished. The galaxy may already be filled with such relics, artifacts of civilizations extinguished, indistinguishable from stone, wandering unnoticed. This is the most poignant resolution of the paradox, that the universe is not empty of civilization, but full of its remnants, that the galaxy is a graveyard of fragments drifting endlessly, silent and unseen. And yet, within this loneliness, there is also beauty. To stand beneath the night sky and know that every faint point of light may have cast its fragments into the current. To imagine that the very meteors streaking through Earth's atmosphere may once have belonged to alien systems, carrying with them the chemistry of distant stars. To realize that the universe itself is an ocean, and that we too are adrift within its tides. This perspective does not erase the silence, it transforms it. Silence becomes not emptiness, but poetry, a reminder that the cosmos does not owe us voices, or contact or answers. What it offers are fragments, and fragments are enough to reveal that we are part of something larger, something older, something vast beyond comprehension. The fragility of civilizations becomes clearer in this light. If the galaxy is truly abundant in fragments, then it is not matter that is rare, but meaning. Worlds may form and perish endlessly, but intelligence may arise only briefly, like lightning across a dark sea. The drift of fragments may outlast intelligence itself, reducing civilizations to fossils before their voices can ever be heard. This is not despair, it is humility, for in recognizing fragility, one also recognizes value. Every word spoken, every signal broadcast, every fragment launched into space becomes part of the drift. Every act of civilization is an attempt to outlast silence. The poetry of cosmic drift lies in its paradoxical intimacy. Fragments travel for unimaginable distances, through darkness without end, without destination, without witness. And yet, by chance, some brush past Earth, this small fragile world orbiting an ordinary star in an ordinary spiral arm. For a brief moment, they are noticed. For a brief moment, their silence is broken by human recognition. Then they pass on, vanishing back into the dark. Their stories remain unfinished, their mysteries unresolved, but their presence lingers in memory, and in that memory lies meaning. Perhaps civilizations are not meant to fill the galaxy with voices. Perhaps their legacy is fragments, drifting endlessly. Perhaps meaning itself is not in permanence, but in encounter. The fleeting moment when two currents intersect, or when a fragment passes close enough to be seen, when silence becomes recognition. In this way, the interstellar visitors are more than objects. They are mirrors. They show us our fragility, our impermanence, our place within the cosmic drift. They remind us that silence is not absence, but inevitability. And yet, within inevitability there is beauty, for to drift is to endure. To endure is to be remembered, and to be remembered is to live, even in silence. The cosmic drift continues. Countless fragments wander between stars. Some will pass Earth unnoticed, a few will be seen, fewer still may be intercepted, studied, understood. Each one is a meditation on loneliness, a whisper of fragility, a poem written not in words but in motion. And in their passing they leave behind a question. Will humanity itself become only fragments in the drift? Or will it endure long enough to find meaning in the silence and to leave behind not only ruins, but recognition? The Milky Way stretches across the night sky, an arc of starlight so immense it defies comprehension. Within it, hundreds of billions of suns burn. Around them, countless planets circle in quiet orbits. Between them, fragments drift, stone, ice and dust, cast outward into the darkness, wandering endlessly. This is the great current of the galaxy, the silent tide in which Earth itself is immersed. And within this silence lies a question older than civilization. Are we alone? The paradox of Fermi lingers, sharp as ever. Probability suggests abundance, observation yields quiet. The contradiction has haunted astronomers, philosophers and dreamers for generations. Yet perhaps the paradox is not a riddle waiting to be solved, but a mirror held before humanity. Perhaps the silence is not emptiness, but message. Not a void, but a challenge. To learn how to listen differently. The interstellar visitors, Oumuamua, Borisov, Atlas, embodied this challenge. They were not signals beamed across the void, not beacons flashing with intent. They were fragments, mute, unadorned, drifting in from alien systems. And yet, in their silence, they spoke. They revealed that the solar system is open, that exchange is constant, that humanity is already part of a galactic dialogue it has only just begun to recognize. Perhaps civilizations do not announce themselves in ways humanity expects. Perhaps they do not build Dyson spheres or broadcast signals across light years. Perhaps they leave behind fragments, artifacts, fossils scattered into the interstellar current. Perhaps the universe already speaks, but in whispers, not in shouts. To hear such whispers requires patience, it requires humility, it requires the courage to admit that contact may not come in the form of voices, but in the form of stone. The silence of the stars is often interpreted as loneliness, but silence has other meanings. It can be reverence, waiting, the pause before recognition. The fragments drifting into the solar system may be part of this silence, subtle, understated, yet profound. They are reminders that connection is possible even if it is not immediate. That meaning may exist even if it is not obvious. That the universe may not be empty, but simply quiet. In this light, the Fermi paradox is transformed. It is not the absence of company, it is the presence of subtlety. It is the reminder that humanity must expand its imagination to meet the cosmos on its own terms, not on human terms alone. The role of humanity within this silence is not passive, it is active. To listen differently is to build instruments that see more deeply, missions that chase visitors, detectors that sift the faint from the invisible. It is to cultivate a philosophy of openness, to treat anomalies not only as errors to be dismissed, but as windows to possibilities not yet understood. Already humanity has begun to prepare. The Rubin Observatory will open its eye, sweeping the sky for faint motion. The James Webb Space Telescope will read the chemistry of distant fragments. Spacecraft like the Comet Interceptor will wait in readiness, prepared to pursue the next messenger. Each step is an act of listening, an attempt to hear the universe in its whispers, but listening also requires reflection. For the silence may not be theirs alone, it may be ours. Civilization itself is fragile, its voice faint. The great silence may one day include Earth, unless humanity learns to endure. To survive is to speak against the silence. To endure is to become part of the galactic chorus, however faint its song may be. The camera lingers on the Milky Way. Billions of stars shimmer in silence. each surrounded by perhaps unseen worlds, each casting fragments into the dark. Somewhere perhaps civilizations have risen and fallen. Somewhere perhaps others endure. But whether alone or not, humanity is already woven into this tapestry. Every probe launched outward, every fragment of Earth cast into space, every detection of an interstellar visitor is part of the dialogue. The role of humanity in the silence is to listen and to answer. Perhaps we are not alone. Perhaps the galaxy is alive with civilizations whose traces drift among the quadrillions of interstellar objects. Perhaps the universe speaks, but in a language of fragments, fossils, and whispers. To hear it, we must learn not only to look, but to listen differently. The camera fades, pulling back from Earth, from the solar system into the spiral arms of the Milky Way. The stars remain silent. The fragments continue to drift. And within the silence, humanity waits, not in despair, but in wonder, ready at last to hear the whispers of the universe.